Okay, so we are going to start. Welcome to this Nextflow tutorial. I'll just introduce myself, and Marcel here is with me to continue the workshop of today. So my name is Francesco Lescai. I work at the University of Pavia. I'm associate professor of bioinformatics, and I've been a Nextflow user and developer for quite a long time, and I'm Nextflow ambassador. Marcel.
Hello, everyone. My name is Marcel. I'm a senior developer advocate at Sequeira, which is the company who creates Nextflow. I'm also a core team member in NFCore, which is a very famous project for creating best standards for writing Nextflow pipelines, and also hosts lots of assets like modules, workflows, and pipelines.
Okay, so before we start with a few introductory concepts, I would ask you to open the environment that will be used for today's workshop. So you will find the link in the chat of the Juno platform on your right-hand side of the screen. But you should go to the URL, which is training.nextflow.io. And here, if you choose Hello Nextflow, you will see a link that asks you to open the environment that we will be using today in GitHub Codespaces. It will take a little bit to spin up. So if you do it now, when we will be ready to go hands-on, you will have the environment open and ready for you. So just click on this link here and open it in a new tab. You should be on with your GitHub account. You just select Create New Code Space. And this will start setting up the environment for you. It will take a little bit. You will see here that it's going to build the code space while we will have our introductory words. So the first thing I would like to do is stop for a moment on some of the key concepts behind Nextflow, and have a bit of an overview of this workflow manager system or workflow engine. There are many ways to define softwares like Nextflow. So I will start from the very basic concept, which is, what is a workflow? The workflow is a set of procedures which bring you from some data that you want to process to the results. It can be an analysis, it can be a report, it can be another set of processed data. Now, when we talk about a workflow, in reality, we are talking about each single step that is needed to go from the data to your result. In which order, in which sequence, and which are the dependencies of these different steps. Each of these steps has to be defined. So you need to specify what software you are using to execute or to process the data in step one. And in a reproducible environment, you also have to specify what version of that software you have been using, which date you have run the analysis on, and which piece of data was analyzed in each of the specific steps. This particular step definition in Nextflow is called process. So a process, we will see again in a minute, is the piece where you define what the step is, what kind of software is going to use, and what operations are going to be executed in that step. Now, this is a key element, of course, but there's another concept which is quite unique to Nextflow and where the software actually takes the name from, which is the idea of a channel. As you can see here, if I have a data set or a package of data, that's how I like to call it, it will flow through what is called a channel. And these packages of data are flown through a process, and they will be processed through what is being defined in the process definition code. Each task in this case is an execution of that process on a specific data package. I prefer to use the name package in this sense, in the sense that because a data package in reality can be multiple files. If you think about, for example, a BAM file, which is a file representing an alignment, usually that travels together with the index of the alignment. In a similar thing, if you have a VCF file containing variants, usually it travels together with an index file. So generally, you ship them together into an execution. And that is exactly what happens when the task produces results. All the results of the tasks defined by a specific process are then flown through an output channel. And these concepts of the channels is actually the heart of what Nextflow is, because the presence of data and how many data package you have in a channel defines if and when a process, or in this case, a specific task, is executed on that specific data package. When the data that flow, the data packages that flow through a channel are exhausted, consumed, then that process is not going to be executed anymore. And this is basically what makes Nextflow very flexible, in the sense that you can build incredibly complex pipeline where the execution, the trigger to execute different steps in the workflow that we defined earlier, are defined by the data themselves. The availability of certain data and the dependencies between the different steps, which are defined by the input and the output connected through a channel, are what actually makes the engine work. And this concept is very important. We will see it when we go hands-on in the code. But this is everything that you really need to understand in order to understand how Nextflow does its magic. Now, the key concepts I would like you to bring into the hands-on part that we're going to start very soon are these three concepts that I just touched upon. So the idea of a channel, which is basically a queue designed, as I said, to shuttle data packages from one step to another of the workflow. A process, which is where you define the operations that a specific step of the pipeline should accomplish. Now, the definition, like in the examples I made, can be lots of things. Can be the software you're going to use, can be the code operation that is going to be executed with that software, can be the name or the system for naming the outputs, and so on. We will see examples of all of these. And then the task, which is the execution of a particular process with specific data that are flowing through the channel. By keeping this in mind, you have everything you need to go on with the next part of the core part of the tutorial today. Now, of course, since you're here, you already have a motivation to learn Nextflow for sure. But in the beginning, it seems quite an effort to start learning a new language to define and orchestrate your pipeline. However, I would like to stress some of the reasons, at least the reasons that I find particularly motivating for me in adopting Nextflow for your pipelines or for your daily work. Once you've gone through the effort of defining your pipelines with Nextflow, then they are easier to maintain. I've changed, like many of us perhaps, workplace in my career. And if you have your pipelines written in Nextflow, you change computing environment, you change scheduler, you change ways of executing your code, but it becomes suddenly easier to port with Nextflow. So it becomes easier to maintain, it becomes easier to port, and that saves you a lot of trouble, especially in our line of work. It's easier to report what you do because usually you get a report definition of different types of the execution of the pipeline at the end, which is always very useful. Also to document the versions of the software you have used, and therefore it becomes easier to publish the results of your work if you use this kind of systematic way of orchestrating your pipelines. Of course, you have to learn a new syntax. We will see the most important parts of it today. And you will have, in some ways, depending on how you normally write your code, rethink a little bit the workflow with this logic that I mentioned, where the data is actually the trigger and the driver of what happens in your workflow. But as you can see, the balance of the scale here is definitely on the positives, and this is all you need to know, at least from my point of view, of why you should actually learn Nextflow and adopt Nextflow in your daily work. Now, what can you expect to learn today? There's a lot to cover, as you might imagine. We will not be able to cover most of the advanced stuff, but as you will see, the training website for Nextflow has been very well curated. So the idea of today is to give you the basis to start using Nextflow components, to learn how to build a simple but multi-step workflow. And in this way, you will learn how to apply the key concepts that I mentioned until now, and use this information to go further. So to start looking at operators, channel factories, more complex things, launch a Nextflow workflow, which is going to enable you to access and use, for example, many of the already available pipelines in the NF core. I will mention this later. And then you can use all this information to go through the training website and go deeper with the more advanced stuff that we will see in the website. So without further ado, let's go to the training website just to show you what I was mentioning. Today, we will cover at least these 4 parts if we manage. And please remember that you have a Q&A chat where you can ask for questions. If there is any problem from some of you in following, I'm going too fast, please don't hesitate and stop me. Marcel is going to warn me if there is anybody who needs a pause or me to repeat some things. And I will do the same for the parts that Marcel will cover. So we will alternate each other. And we will start covering these first 4 parts. But as you can see, there's more. There's a part specific for containers. And then these initial tutorial is going to cover also config. So you can continue yourself if you don't manage to cover all these parts today. So let's go to the environment that it should be open right now. And the first thing that I want to bring your attention to is that you should find this part here where you have a top part, which is basically a code editor. Let me zoom a little bit more. Maybe it's easier to see the screen. So you will see here that in the bottom part, you have a terminal, and this is where we're going to execute our code. In the left-hand side part, this is like a explorer or a browser or a finder, depends if you have Windows or Mac. And the part that we are covering today is in the Hello Nextflow part. So wherever we are, we should go to the Hello Nextflow part here. And if you manage to be on any other part of the terminal, just CD into these path, which is workspaces, training, and then again, Hello Nextflow, which is where we have all the information here. If we run a tree command and we stop ourselves at 2 levels, you see that there are several files in this part here. The files that end with a .nf, these are workflow scripts, parts that are named with Nextflow code that can be executed. Then we have the greetings.csv. This is a comma-separated value file that we're going to use later on. And then we have, for example, the Nextflow config, which is a small file that contains a configuration that allows Nextflow to be executed. So remember that if you are lost in the terminal and you don't know where to find the files, you can either scroll through the Explorer part here, where you can see the code that we're going to use, or again, you can use CD and CD into this path, which is workspaces, training, Hello Nextflow. I'm going to zoom in a little bit more again. And then if you want to open a specific file, you can also type the command code and the name of the file. And this is going to be open on the window that you have above. Okay, so I think we are ready now to start our hello world, which is usually the very first thing that everybody learns in bioinformatics in every programming language. I'm going to stop my camera so you can probably enlarge the full screen for what I'm showing, and then you can follow better what I'm showing here. So let's start with the hello world. Now, like I said, this is something that is going to be used and has been used all the times in bioinformatics to start any programming language. So, for example, in this terminal here, we are in a Bash environment, as you can see here in the top right hand corner of the terminal. And if we type the command echo and we write the sentence "hello world" with an exclamation mark or not, as you prefer, you can see that we are basically printing in the standard output this sentence. Now, if we did redirect the output of hello world into a file, for example, output.txt, we will not see anything appearing at the in the terminal because we have redirected the string hello world into a text file called output.txt. Now we can print the content of that file with the cat command, as you can see here, and that is going to show exactly what we printed in the standard error in the standard output before, but it's been written into the output txt. Now, like I said, another thing that we can do is to use the command code on the file output txt, and as you can see, the command code is going to open in the editor that we have in the upper part of this window, and we can use the editor if we want to edit this file. This is going to be useful particularly for the next parts where we are going to edit files that we have already prepared for you to start looking into Nextflow code. Right, one of these files is the hello world Nextflow, which you can see here. So you can open the file just by clicking with a left click on the hello world Nextflow file here, or you can open it with the code hello world like this. So if I closed this one, you can use code and it will open in the same way. Let's start by looking at the code so we can try and understand a little bit how this Nextflow code is written here. Now, as you can see, we have two parts. One part, which is introduced by the word process, and one part, which is introduced by the word workflow. Now, this is precisely what I mentioned in the introductory concepts. This first block here is the block of code that describes a process, that is a definition of an operation that I want to execute on a specific data. Now here we don't have any input for the moment, so we're going to look at these two different sections of the process definition. We have a block which is introduced by the output word, where we say that the output is going to be path output.txt. Now, the output definition has two things here. It defines a path qualifier, meaning that our output is going to be either a file or a directory, and then is going to say that what the process should expect is a file called output.txt. Now, this part here, the word that I use, the expect, is very important because this block here the output definition does not determine what output is going to be created. It simply declares what is the expected output. So Nextflow itself can look for this specific file or the expected output once the execution is complete and flow this output through the output channel that is going to be defined. What is going to create the output that the process of Nextflow should expect is this section here, the actual block where the operations are executed. So this script part is the block where you actually define what the process is going to execute. And in this case, you can see that we started very simple, and we started with an echo hello world redirected into a file called output.txt. So exactly what we have run a few moments ago in the terminal here. This is precisely the same. So this, as you can see, is probably the very minimal definition of the process, where we have defined a script that is what we want to execute in that process. And then we have told Nextflow to expect, as a result of that execution, a file that is going to be called output.txt. This is everything that you need to start working with Nextflow. Now, if we have defined one single step for our workflow, then we have to define what the workflow is. And that is what the block, the second block does. So the second block of code describes the workflow itself. And the workflow definition starts with the keyword workflow, and then can be followed by an optional name or not. So this is what distinguishes the, let's say, named workflow from the main workflow in this case. This is a very minimal definition of a workflow. And of course, in a real world pipeline, the workflow typically contains multiple calls to processes connected by different channels. Now, as you can see here, what is being done in the workflow is the execution of this process that we defined here under the name say hello. Now, this could be familiar to many of you who program in different languages, because to me, I tend to use this parallel example where you think about defining a function and executing a function. And if you're familiar with Python or many other programming languages, this is not very different from that thing. You first define the process, and then you call for the process as if it were a function here. There are no arguments. As you see, there's no input definition here. So when you call for the process, there's just open and closing parentheses without any argument, because there is no argument or input definition here. So let's let's run this workflow and see what happens. Now, since we said that we are here in this folder, Hello Nextflow, the code is located in the same folder. We can just run this workflow, very minimal definition, by typing Nextflow, run, and then the name of the file that we want to run, which is Nextflow run hello world .nf. We hit enter. As you can see, there's a couple of things here that we can gather from the screen. So first of all, it tells you what kind of version of Nextflow you are currently executing. Then the workflow environment is assigning a random name to the workflow execution. In this case, is nicely called Hungry Point Care, and this is something that you can refer to in order to identify that exact execution of your workflow code. Then you can gather a few additional information. The first one, you can see it here. Now we didn't run the workflow in machines or in a cluster environment or on the cloud. So the executor here is just the local machine where we are actually located. And then we can see one very important thing here that says that our workflow has executed one tasks referring to the process definition, say hello. If we had to run or to execute that process multiple times, we would see here the number of times that Nextflow expects to execute that process. And then we would see here the number of tasks of that process that have been actually executed. And you can see here with the green tick that all the expected tasks have been executed. This is quite important because it gives you an immediate overview of what actually happened. All right, so now there's a very important element that we're going to bring over from the very simple execution that we run right now to the very complex execution of much more complex processes, which is how Nextflow stores the temporary files during the execution. If we wanted to see where this output txt has been put, we need to search in a folder which is called work. So we can look in here and go to the work directory, which has been created during the execution that I just launched a few minutes ago. In this work directory here, you can see that now we have one additional folder, which is called 28. Now you will notice probably the parallel here with the numbers that you have in the square parentheses before the name of the process. The first number is the name of the directory, the top hierarchy directory, where the execution folder is located. The second, as you can see here, if we go to the 28, you can see that the second part is just the beginning of these hashed code, alphanumeric code of the folder where the files have been located. In this case, we have only one process, so this tree here brings us only to one folder. We have executed one task, and we have one folder where that has been executed. So let's have a look at how this is structured. For example, if we want to look at this from a more higher perspective, using again the command tree of this work. So you see here that in that folder 28 and then the hashed name of the task execution, we have several files. These files here are very important because they contain lots of useful information that might be useful, perhaps not in this very simple execution that we just run, but for debugging of more complex execution. If you have an error, you want to understand what happened and possibly correct your code or identify where the error was coming from, this is the place to look at. So if we look at a couple of these things here, we can briefly identify what happened. So let's go again to the work 28 and then this hash. And then we said we have all these files here. And then, for example, we can look at cat.command.sh. And you can see that this is actually the translation in Bash, in this case, .sh, in the shell language of the command that the process was going to execute. Then if we look at the command run, we will see lots of more complex code that is going to show how this is actually being run. And we will see this probably later on in the tutorial. But this is the folder now where we also find the output file that we have created with this script here. So our hello world has been redirected inside this output file, which is located into this work folder for the task execution. Now, as you might see, I'm sure you're probably thinking about it right now, this is not particularly convenient, right? I mean, looking into the tree of the execution and in order to find the file that was supposed to be your results. Now, this is the important thing, because this structure is used by Nextflow to organize in a hierarchical way each execution of the tasks in a confined way that allows you to debug what happened at which moment for which task for which data package. But if we want to save specifically our results somewhere, we need to publish them, and that's exactly how it's called in the Nextflow syntax, and we will see this in a moment. So let's go back to our main folder here in the Hello Nextflow folder, and then let's start modifying this process definition here. So right now, the process definition starts with an output. We're going to add here another directive, which is called publish dir. Publish dir allows us to define a folder. In this case, for example, it could be results, where we want to publish what is being defined as an output of the process. And we also can define which mode. Nextflow uses a lot symbolic links. In this case, we want to copy our results because that's the easiest way to make sure that all the results, even if we delete the work folders, they are going to be simply copied in here. So what we did here is basically add a publish directory, a publish dir directive, where we specify the directory where we want to save our files, which is results. And then we say that the way we want our file or our expected output to be located in this results folder is by copying the file from the work directory that we just identified into the publish dir. So if we save our code here and we execute again our workflow with the Nextflow run, then you see that we have a new folder here that has just appeared called result, and that the output.txt has been put into that folder. Okay, so that is very simple, as you can see, and I have to point you to the fact that now there is also a newer syntax that has been documented. You can find the documentation in Nextflow that will also allow to declare and publish workflow level outputs, so things can be, let's say, orchestrated at a workflow level in a more systematic way without necessarily defining the publish folder at a process level. Now, what is important and what is also the advantage of Nextflow and the reason why we have these let's say, complex hierarchical structure of this work folder that we navigated a few moments ago is that one important feature of workflow engines, and in a case like Nextflow in particular, is the fact that you can resume your work if you interrupted the workflow for some reasons. So let's imagine that you have an error, you need to debug and correct your code, or for some reasons the execution is stopped. You can simply resume your workflow from the step where it was stopped without the need of executing again all the steps that you ran before. So this is simply done by adding an option here, which is -resume. And if you run exactly this code with the dash resume, now there is nothing to be resumed if you imagine, because we haven't modified the code of our workflow. We haven't changed anything. We didn't have any error. But if you compare this execution here with this execution here, you will see that next to the 1 of 1 tasks counter, you have now this word cached, which means that this task is reported as completed, but it hasn't been executed, it hasn't been cached. It was executed before, and Nextflow recognizes, thanks to this hierarchical structure of the folder work, that this specific task has been executed before. And it doesn't waste the computational resources in executing this task again. So this is really convenient because you might need it in many situations. Like I said, you might be writing your own pipeline, and you might need to debug some things. And this is especially time consuming, especially if you imagine that you need to rerun your entire pipeline just to correct, for example, a syntax error in a process definition. So this is going to be very useful. Or another case, which is probably frequent, if you run on the cloud, you can use what is called spot instances. Spot instances are not reserved for you. If another user demands on demand for the virtual machine where you're running your tasks, your execution is going to be stopped. Now, with this feature, you're going to pay much less because you're using spot instances. And if your task is stopped, you can simply resume or execute it again. And this is done also automatically. We will see this in configurations later on. Now, these work folder, of course, can also be a source of disk space that is being consumed. So especially once you have completed your workflow, you might want to remove all the intermediate files that are contained into the work folder. Now, this can be done relatively easy because Nextflow has a functionality which is called the Nextflow clean. If we use this command, we can clean everything in the work folder before a specific execution. And this is where I pointed you to the name of this specific execution, because we can use these command, for example, to say clean before marvelous Sanger. And then in this case, we can add -n simply to have a dry run and see what would be removed. And as you can see, Nextflow is telling us that executing this command, so Nextflow clean before marvelous Sanger, would actually remove the folder that is called work28 and this hash command here. So if we run these without the flag n and we add the flag f, this is actually going to remove that folder, and that's what's being communicated here. Okay, so I see that someone asked in the Q&A also, how do you save the code? Apologies, I just did a command or Control S on the file that I have opened. So this probably wasn't going to be shown into the screen sharing. Simply like you would do in your editor or for any other file that you have at hand. Okay, so let's go on and try and continue working on the code that we have in front of us, where we simply have these simple definition. Now, like I just said, these process definitions say hello is incredibly minimal, right? If you imagine how you would define a step of the execution inside a workflow, normally you would think that you need an input and an output. And that's exactly what we're going to do right now. In this process definition, we don't have any input definition. If we want to make the process slightly more realistic, then we can add here an input block and define what our input is going to be. So we have seen in this part here that we have a path that says that the expected output is going to be a file that is contained in the definition of the type path. And in this case, we are writing val, which means that we expect a value to be received by the process that is going to be executed. And we are going to name this value greeting. And then again, Command S in the Mac or Control S to save this file here. So what happens here is that now you can see that we have a more formal definition of the process where we do have an input definition of type value, and then we have an output definition of type path, which corresponds again to a directory or a file. Now, this thing here also allows us to do a couple of things, because now we have one variable that is going to be, or a value that is going to be created when the process is going to be executed, that will be initiated with the value that is going to be received in the process execution. So we can use it in order to change these and make these more flexible. So now we can use this variable here, greeting, and this allows us to pass in a more flexible way a value to the process and then output into the file output.txt any value that has been passed as an input to the process that is going to be executed. Okay, so by doing this, we simply prepended the $sign here to the name of the variable that has been defined here in the input. And this is exactly like any other programming language. Again, if you think at Bash, you define a value and then you use the value with the $sign. That's a typical example that that we could make. Now, how do we make these flexible? We can do it in several ways. So one important thing is that we can define a parameter when we execute it here. So we could pass this variable here as a parameter to the execution of Nextflow. So in order to make sure that we have a workflow that respects the execution of the process as it's been defined, now the call to the process here must have an argument, because when this is going to be executed during the workflow, it will expect one argument corresponding to type value that is going to be stored into the variable greeting. So it means that when we write the workflow part in here, we need to add a value that is going to be passed as an input to the process that is going to be executed. This can be done in several ways. We could hard code the string right now here, but of course, what we want to do now is to try and step up a little bit more and make these really more flexible. So one way to pass a value when we execute the workflow is to pass it as a parameter of the Nextflow run execution. Every parameter that is passed in the Nextflow run execution is going to be stored under the list called params. So if we write params dot params maybe with the correct spelling, params dot greetings, greeting here. Then when we execute Nextflow, so we write here, say hello, open parenthesis, params dot greeting, we can execute Nextflow here again, like before. So we can write Nextflow run, and then again, hello world.nf. But now we add dash dash greeting, and we can write what we prefer. For example, we can write it in French. I don't know if there's anybody of you who's French, will forgive me for my French pronunciation. There's going to be bonjour, bonjour le monde, like this. Now, before I run this execution, I just want to point you to a couple of things, which is very important. So here we have used a single dash. Here we are using a double dash. Now this is important because single dash are Nextflow options. Double dash are pipeline parameters. This is very important to remember, because now it means that after the double dash, the name that I'm writing here, the word that I'm writing here, is where this argument is going to be stored under the list params. So of course, what I use here and what I write here has to be the same. This is an important concept that I would like you to really to point you to. So if we run again the workflow now in this way, you can see here that it's executed fine. This is what we expected. But if we open the file here on the left-hand side, you can see that now the output.txt contains the string that I passed during the command line interface execution with the param greeting. So just to point out again these very important things. So number one, when you execute Nextflow, there's an important difference between the things that you write with a single dash and the things that you write with a double dash. The things that you write with a single dash or hyphen is a parameter that modifies a Nextflow setting. So it's a Nextflow option. When you use double hyphen, double dash, those are parameters that apply to a pipeline. And in this case, they are stored under a object that is called params, and you call or you retrieve the values that you stored under that parameter using the name that you passed on the command line here. Okay, so this is the main parallelism here. Now, an important thing is that if I didn't pass this parameter and I wrote params.greeting in here, I might run into problems because I haven't defined a default which is going to be used in case I don't pass any parameter to the pipeline. So I need to change my workflow code in order to define the specific declaration for the default of the parameters. So what we can do here is to say parameters default, or for example, write it in a let's say more complex way. We can write multi-lines in these like this, where we write, for example, these, and then we end it up in this way. So when you do something like this, we can write multi-line comments. Okay, and here we can store our default. So parameters, params dot greeting equals, and then we can define what we would like this to be. For example, we can write it like Hola Mundo. So now you will see a couple of things. If we save this file, remember to save it, we can execute this again without passing a command line parameter. And if we look into our output, you see that now the value that's being used is the one that we have defined as default. Okay. If we change it again and we pass another greeting, let's write it in Italian for a change. Then we look into the file and you can see that this is what's being used. So there is a hierarchy of how you pass these parameters. The ones that you pass at the command line here clearly have a higher importance than the parameters that you define here in the as a default. Okay, so that's actually going to be used only if you didn't pass a greeting parameter here. Okay, so this is the first part for the hello world part. Before I pass the floor to Marcel, is there any specific question or something that you would like me to show you again or explain again for about what we have just seen? I'm looking at the Q&A chat if there is anything. Otherwise, I will just leave the floor to Marcel for... Okay, there is, how would it look to pass multiple parameters? Yes, sure. That would exactly look in the very same way, in the sense that, of course, you need to have the parameters used or defined somewhere. But let's imagine that I'm running these, and let's imagine that I had, for example, another parameter that would be called out name. For example, the name of the output. We will see this in a moment. You would simply pass another dash dash or double hyphen name of the parameter you want to use, and you would pass, for example, instead of calling output.txt, I would call it, for example, hello world.txt. In order for this to work, of course, you would have to define this in the workflow as well, in a way that is going to be used. Otherwise, it's just another parameter that you pass it, but it's not going to be used. You don't have to pass them in the same order because that's a very good question. These are named parameters. Okay, so again, if you think about other programming languages, normally when you define a function, you have parameters in a specific order only if you don't define them by name. If you call the parameter by name, then you can pass them by any order. This is, for example, a very typical exercise we do in Python when you show the difference between a named parameter or a positional argument of a function. What is important for the next question that I see in terms of the order? What has to be ordered that is now in the chat now is the way you defined it in the process. This is going to be covered in a moment, you will see in the next part. But of course, while here in the execution, you can pass the parameters simply because you name them here. When you pass them here in the workflow, they have to be passed in the order that you have defined them into the input block, okay? Because this is not named. This is simply ordered. This is a positional argument. And therefore, when you execute the process here, this is going to be a positional argument as well, okay? So there's a difference between passing these parameters here and using some parameters as arguments of the process definition. Okay, I will stop sharing my screen and I will simply pass the screen to Marcel.
Hi everyone, let me share here the correct window. Can you see my GitHub code spaces window? Can you see it, Francesco? Can you confirm?
Yes.
Good. Okay, so regarding one of the questions that were asked, so these are the parts of the training. You're not sure if you're going to go through all these parts, but for example, if you like on the first part, basically what we saw, what Francesco showed was this script, right? We have one process, one step in our pipeline called say hello. It receives one input, it outputs one output, right? We have a pipeline parameter, we have a workflow calling one process. And then one of you asked, what if I have more than one input? And you could say, what if I have more than one value in a single output? Or what if I want to have multiple outputs? So this will be shown today in the other parts, right? So here in the part 2, the hello channels, the one I'm going to present now, we're going to learn what if I have multiple values for the same input. I'm going to show you how to do this here. Then Francesco will present to you hello workflow, which will help you add multiple inputs. There's one here which is pass more than one input to a process, right? Then we're going to go to hello modules, and then each time we add another layer of complexity and we get closer to what a real pipeline looks like, right? So don't worry, we're going to cover all this, each step at a time, right? So again, this is the pipeline, the Nextflow pipeline that we got at the end. It works, it does something, but it's too simple, let's say. In here, if I want to say hello and store it to a file, usually I don't want to say just hello or just one value, right? I have multiple values that I want to feed into my pipeline to do something with that. It could be 1,000 samples. It could be data from 100 clients. You know, even if it's the same input, client name, for example, usually you want to provide a lot of them, because if it's just one time, you can do it manually. This automation comes in handy when you have lots of inputs, lots of values for each of them, lots of steps, and so on, right? So in the second part of the training, this hello channels, we're going to introduce you to this concept called channels. Francesco briefly mentioned during the slides. So channels, there are two. You can see them as a first in, first out queue. If you have lots of samples from patients, the process is going to be called with one sample at a time. And the data structure that's going to organize this inputs will be the channel, right? So, okay, let's start doing a few things here. The first thing is, let's run this script. That is, every time you go to another part of the training, here we are on part 2, right? It provides you with a script, which is the final solution of the part before. So this hello channels, the first script in the hello channels part, it is the end of what we did in part 1 in hello world, right? So the first thing we're going to do is to run this hello channels script, right? And we're going to use the greeting parameter like we did before. Let's say hello ISCB, ISCB. And if we look at the results folder, the output txt file, we're going to see it written here. What if I want to say hello to multiple people or hello in multiple languages, right? This is the type of thing that we want to do here. But before going to multiple values, let's start a bit simpler. Let's go to the workflow block, right? You already learned that this block, workflow, is where the logic is. I can have 20 processes here. If I'm only calling one in the workflow block, only one will be called. If I have processes A, C, D, B in a crazy ordering, it doesn't matter. It matters the ordering I'm going to call here in the workflow block. So the logic of the pipeline is all here in the workflow block, right? So let's start creating a channel, right? And we use for that what we call a channel factory, right? They always start with channel. Let's use channel of, which is the simplest one. I'm going to say here, hello, Francesco. I'm going to start this to a variable. Let's call it greeting ch. It's a variable name. You can name it any way you want. Usually we do underline ch just to make it more explicit that this variable contains a channel, right? So here, creating a channel called greeting underscore ch. The content is hello, Francesco. So now I'm not using parameters anymore, so I'm going to remove this and just put it here, right? With that, let's save, and let's run this pipeline again, but this time without the parameter, right? I run this and look at the results folder. Now we have hello, Francesco, right? So here's the thing. What if I want to have multiple values, right? So I want to say hello, Francesco. I maybe want to say hello, Marcel, or hello, or hi, Bob. Now, as you can see, I have still a channel, but now I have 3 elements inside my channel. Sometimes people like to space it like this to make it more obvious. There are 3 elements, but it's just a matter of spacing and organization. It's the same thing, right? By doing it like this, if I run again my pipeline, something interesting is going to happen. Before, we had 1 of 1, because there was only 1 input, which was hello, Francesco, right? Now it says 3 of 3. So there were 3 process calls. The say hello call, the say hello process was called 3 times. They all were successful. Here's the name of the say hello, right? And here we have the ID, the hash of each task, each process call. And you saw this before with Francesco, all the files we have inside each of these task work directories, right? If I go now to the results folder and I see again the content of the output txt, I'm going to say hello, Marcel. And then you may be asking, why do I have only hello, Marcel, if I said Francesco, Marcel, Bob? The thing is, again, these are 3 tasks, right? It's not only 1. If I do this with this option here, this Nextflow option, only 1 dash, right? So it's the Nextflow option. If I set unc-log to false, instead of having 1 row per process, I'm going to have 1 row per process call. So now I have the ID of each of these tasks. Then I can go to the work, C5, and get this comment out. Oops, not coming out. See the 1 second. Okay, there was something hiding in my screen. C5 to be. If I go here and I see the output.txt, I'm going to say hello, Francesco. If I go to another one, let's say 7D43, I'm going to say hello, Bob. So each task is correctly writing the correct file with the correct information. Why do I have only 1 output.txt in my results folder, in my published folder, with only 1 value? And the reason is because they have the same name. They're all named output.txt, right? Which means that the last one to run, which was this 95, 23, and so on, hello, Marcel, is the one that's going to override all the other ones. And that's why when I look at the results folder, I see hello, Marcel, right? So what we want to do is, instead of having this fixed constant name for the output file of the say hello process, we want to have something else. How can I have a unique name so that these file names won't clash? The way to do this is to use a variable here. And we could use, for example, the greeting variable, right? It would be hello, Marcel. So let's remove the spaces just to make it easier, because in some of the computers, the space may be an issue. I just say hi, hello, and ciao. Let's simplify this here. So here I want now to have hi output, hello output, ciao output. So because my greetings are always different, the files will be unique. One thing you have to pay attention, though, is that when you have a single quote, right, a single quote, everything here is a literal. So this is going to be the file name. If I want this variable to be interpolated or extrapolated, you need to use the double quotes. With double quotes, this will be
overwritten by the value of the greeting variable, right? So let's now run again this pipeline. If you look at the results folder here, oops, there's an error. Oh, sorry. So this is a nice opportunity to explain one of the Nextflow errors, right? So I'm saying from now on that the say hello process has an output file that starts with the value of the greeting output followed by dash output.txt. But here, when we go to the script block, I'm still saving to the same file. So Nextflow threw an error saying that the output file hi-output.txt, it's expected, but it's missing. And it's correct because we didn't create it. So what we have to do here is the same thing. We're going to say greeting dash output. And now it's going to be correct. So now as you can see here in the results folder, I have 3 new files. Chow output has chow, hello output has hello, and hi output has hi. Again, in the task correct directories, everything was fine. It was only when publishing to the results folder, which is the same folder for all the tasks, that we had a clash and the files kept overwriting the other one, right? So by setting unique file names, we managed to have all these different files. In real life, you could have a folder with an ID with all the files inside specific to that ID, or you could have the files with the ID in the name like we are doing here, right? But the point of this exercise is to show you that you can have unique file names based on the value of one of the variables that you have in your process, right? Good. So far, based on a few of the concepts that you've been introduced, we learned that we have processes in Nextflow, which basically are the steps. Usually, whenever you organize in your mind, in your thoughts, how the pipeline is going to work, most of the time, each step is going to be one process. So fine, Nextflow processes, they are steps. You understand already what's a pipeline. And for a channel, you see that the only way to feed information to a process is through channels. And the only information that leaves a process is also channels. So all this communication to, from, and between processes, they need to go through channels. You also learn that. But then you could say that in the first part, we didn't create a channel. So how is it possible that we fed information to a process if we didn't use a channel? Whenever you send a single value to a process, Nextflow will automatically convert that to a channel. But it's a channel of a single value, and that's usually not what you want. You want to have many values, right? So creating channel is the way to go. The next concept that you have to know is the concept of a Nextflow operator. Whenever you have a channel and you want to do something with this channel, one way is to use a process. If I have 3 samples and I want to run a software on each of these 3 samples, good, I'm going to create a process. But sometimes what you want to do is simpler. You don't want to create a process for that. So you want to use a function to do something on this data, right? So functions that apply to Nextflow processes, they are called Nextflow operators. So very often when working with Nextflow, you will use operators, right? Here we want to transform the content of this channel. So basically we're going to use an operator, right? So for example, we have here these 3 values, right? But the plan is to, instead of listing them here, I want to provide a variable like greeting array, right? In this greeting array, I wanted to contain the values that I want to pass, right? This is not always the way you want to do that. Usually you're going to read from a file, from a sample sheet or something like this. But here is just an example to learn how to use channel operators, right? So here the plan is to create an array called greeting array, and I'm going to create a channel based on this array. So let's run this pipeline and see what is going to happen. For those wondering how I clean my screen, you can just type clear or Control-L, right? And it's going to clean. So here, again, we have the same error we had before. It's saying it's missing the output file. Because if you provide a list like this to a channel, it's like what I said before, you are creating a channel with a single element. The whole list is a single element, right? What you want to do in this case, actually, was to have a list, an array, fed to my channel, but I want each item of the list to be a channel element. I want each of these words to be called in the process each at a time. I don't want to call the process with all these things, right? For that, we can use a channel operator called flatten. And basically what flatten is going to do is to make this list flat. It's one list with 3 values. It's going to remove the list structure, the array structure. It's going to be now just 3 values. And by running this here now, you see that it worked the same time. We could do another example here just to make it clear what flatten is doing. I could do like channel of 1, 2, 3. Let's call this channel 1. And then channel 2 would be channel 1 flatten. We're going to use this operator called view to view the content of a channel. And I'm going to do it like this. Let's see if this is going to work. Oops. So as you can see here, channel 1 was just one element, which is this array of 3 items. But once we flatten it, now we have 3 elements, 1, 2, and 3. So that's what the flatten channel operator does. Let me see what else we have to see here. So again, this is just an example on how to use channel operators. It's not usually the best way to do it, not the way we usually do. Most of the time, what we do is to have a sample sheet, like a file here, greeting.csv, where we have our data here. If it's a sample sheet, we could have like a sample ID, if it's per end or not, some metadata about the sample. We could have lots of information here. And the goal is for the pipeline to read this file, interpret the data, and do something with that. So now, at first, we stopped using parameters. Then we went to channels, then a channel reading from an array. Now we want to read from a file. So this parameter here, it's now going to be a file name. We are going to set a default parameter, like Francesco said. We can always provide it with -- greeting, but if the user doesn't provide any parameter, just runs the pipeline, this is the default file it's going to look for, right? And now, instead of reading from this array, I'm going to read from this file, right? But the thing is, this channel factory, this function to create channels, this channel factory, channel of, is supposed to get strings, values. And here we have now a path to a file, right? So we have to use another channel operator, another channel factory, which is called from path. If you go to .nextflow.io, you're going to see so many different channel operators, which goes totally out of the scope of this training. But I just want to show you that there are so many for filtering, transforming, combining, miscellaneous. There are a lot of different channel operators, right? For reading files, usually we're going to use from path, right? And now we don't need this flatten anymore because it's going to be a single file, right? It expects a single file. It's going to read the contents of this file and then view the channel with each row being an element, right? So let's now do our next row run. Hello, oops, hello channels. So there was an error here. I think we have to change something else in the file here. Let me see. Okay, that's the thing. We are reading from a file, which is this one, but it's not just any text file. We are expecting it to be a CSV, right? We want Nextflow to understand it this way. For that, we need a channel operator, right, called split CSV. And this way, it's going to read the file and then split each row into an element and so on. To show you how it changes, we're going to do something like this. We're going to first view this channel before calling the process and everything else. Before split CSV, then we're gonna split it and then see what happens after split CSV, right? And we're going to comment this here because I don't want to call the process. I just want to see this channel, how it looks like, right? Now we see before split CSV, it's just the path. Nextflow understands it's a path because it's had from path, but it doesn't understand the content. It doesn't interpret the content. But after I use the split CSV, it reads the content, knows it's a comma separated value, and then it's going to separate into 3 elements, each row being an element. Because we just have one word in each row, it's going to be a list with one variable each, right? Let's remove this and leave only the split CSV without the views. Let's uncomment that. If you do Control or Command slash, it's going to remove or add the comment, right? So now let's run this again. And we got another error. What's happening here is that it's missing the output file. Either it's not writing or writing, but it's not with this name, right? Why? Before we had bonjour, hello, hi, and it was easy to put it here. But now the way that split CSV works, it adds these square brackets around the string. So now I'm writing to hello-output, but the process is expecting without the, sorry, it's coming with the bracket, but then it's not writing it this way, right? It's missing this output file. So how can we fix this? Actually, what we need to do is to use another channel operator called map. And basically what map does is, you know, if I have a channel with 10 elements and I want to do something to each of these 10 elements, I'm going to use map. So basically we're going to say, you know, every element of this channel, I'm going to call it item. And I just want to get the first item of this list. So if it's Bob and Susan, for example, I want to get the first element is going to be Bob, and it's 0 index, so it starts at 0. If I say 1, it's going to be Susan. But because now there are only one element, it's always like hello or hi here in the bottom. If I say 0, it's going to get the string for me, the hello, right? So this way, when I run this pipeline again, this time it should work. Okay. So I have now here the hola, the bonjour, and the ciao, which is the content of our greetings CSV. Right? Hello, bonjour. I see someone open the mic. Is it a question or? Okay. Let's see here. So I think for the hello channel, that's basically what we planned, to show some of the channel operators, some channel factories. Again, there are a lot of different channel factories, from list, from path, from as array. Channel operators, we have filter, map, lots of them, right? You can have channels in many different shapes, in forms, and so on, right? One thing we could do is, for example, I could have in this greeting.csv, I could do like, hello, Marcel, bonjour, Maxime, hola, Chris. And here, instead of item 0, I could put item 1, for example. And now when I run this pipeline, instead of getting the first column, hello, bonjour, hola, I would get the first one. And now you see here Marcel output, Maxime output, and Chris output, right? So as you can see, these are very simple examples, but very powerful one. It's very easy to make them do much more complex situations and tasks, right? Is there any question that I can answer, or something someone commented? Let me see. All the questions were answered here in the Q&A, apparently. Let me see the chat. So I think it's good, right? So Francesco, you want to continue with the part 3? Hello, workflow?
Yes. So if everybody is okay, I'll just continue. I'm not sure if you need to stop your sharing. Let's see. Entire screen. This one. Share. Okay. You should see my now, right?
Yeah, I can see yours.
Okay. So someone asked for the code of your x.nf. I reposted something similar, not exactly the same, but the content is very similar. But in the chat, it was sort of flattened without new line marks. So just keeping it on the screen if you want to see it a little bit better right now. So it's just what Marcel has shown in this example. It's simply when you write Nextflow run, it does execute this groovy code if you want, or Nextflow code as it is. It doesn't necessarily have to be a workflow. So the reason why Marcel has used this example here is simply because you can run this code by typing Nextflow run x.nf, and then you execute line by line this code here. One thing that you can see here in my example is that you can see that the order is not the same that I wrote here, right? I mean, you see first this one here, which corresponds to this code here, and then you see these executed first. The reason is because they are not dependent on each other, so they are not executed necessarily in order. And that is something that someone asked before, if tasks can be executed in parallel. The question is yes. The only thing that defines the order of execution is the dependency of input and output. And that's what you do within the workflow. We're using channels. When you define the input of a channel, the input of a process being a channel that is the output of another process, then necessarily one process is executed after the other, because the process has to be triggered by the existence of that data package it's linked through the channel. So unless the process that you defined earlier outputs the output that is expected, which is also the input of the following process is not going to be triggered. And that's basically how Nextflow executes its magic, simply by defining how you connect the different processes through channels. And this is exactly what we are going to look at in this part. So we will see how the data flow from one process to the next. We will see how we can collect the outputs from multiple process calls into a single process call, for example. And we can also look at passing more than one input into a process. So we will appreciate a little bit more what Marcel has just shown, that by reading multiple values from a CSV file, you can actually handle these data flow through the process. So in order to do that, let's start and look at the hello workflow code, which we can start by running hello workflow. Okay, this is exactly the point where we're left, where we write these three different outputs in our results file that you see in green here. They just appeared. Bonjour output, hello output, hola output. Okay, and this is because code hello workflow, you can see here, this is the point where we left with Marcel, where we basically have the input of the process say hello defined, the output defined by containing the name of the file as the greeting that we passed in parameters, and outputting the file this way. This is where we have been left now. Now, in order to see how to connect two processes by a channel, we need to define a second step to this workflow. And we need to be creative here. And let's imagine that we want to uppercase a sentence or our greeting. So as usual, in order to start debugging, we start trying what we would like to put into the script part of our process. We try and execute it in the terminal. So for example, one syntax to convert lowercase to uppercase is to use the tr function, and we convert any character that goes from A to Z. For example, we close the array here, into any character that goes from capital A to capital Z. This would be the code in TR syntax, okay? So we can try this code by using a pipe. So for example, if we had the hello world, let me clear the screen like Marcel said, we Control L, and then we write again, hello world, exclamation mark here, and then we pipe these into TR. And then, like we said, we want to convert anything that goes from A to Z into anything that goes from capital A to capital Z. So instead of redirecting it to a file, let's look at first in the terminal. And then we can see that if we go to upper.output.txt, then we've put these into a file that's called upper-output.txt. Okay, so now we basically have tested the code that we would like to transform into a step of our new workflow. So let's start by typing from scratch a new process definition. Like we said, the process definition starts with the keyword process. And then we have to name the process that we want to define right now. So this could be convert to upper. That's another classical example of coding. Sometimes these, right. So then, like we've done before, we need to define our published dir directory. We want to put these into the results folder again, and we want the mode to be copy. This is identical to the previous process definition here. Then we want to define the input. And this is going to be, this time, a path, because we want to capture the file that we created here, and we want to have this being the input of this process definition. So this is going to be a path, and we're going to define it as a variable, so input file. So whatever is passed to the execution of convert to upper into the workflow will be stored into the value or the variable internal to the process execution that's called input_file. Right, okay, we have an input, we need to define the expected output. Usual way of doing that. So we have now again a path, and that is going to be this time upper, exactly like in the example. And then we want to call it with the name of the input file, but preceded by the upper string. So we are going to take as is the file as an input, and then we're taking the name of that file and we use it to as a variable to define the expected output. Then we have the actual script. As you can see, this is all very simple. We have these three blocks, input, output. And then here we're going to define our code. And we want to say cat. And now we are passing the input file. And we pipe these. So this is exactly what we have done here, okay? So we've done it with an echo here. Here we are simply streaming through the pipe the content of the file that we have captured as an input. But then the code is going to be exactly the same. So we're using TR, and we want to convert anything that goes from A to Z into capital letters. So again, from capital A to capital Z. And we want, this is sometimes the keyboard inverts the letters here. And then we want to redirect these into a file which is called exactly like this. So the expected output is actually what is going to be created here. Okay. Right. So we have composed a second process definition here. We can be cleaner in the code and separate with a space. Right. And then this is wrong as well. So we're going to clean that up. Then, of course, we need to call this process, right? So now we have this definition here, say hello, greeting channel. And then we want to do a call to convert. Like this. And then we need to call the process exactly with the name that we have defined earlier. So I just copied pasted. And that's the call to the process, okay? However, that's what I pointed out earlier when I said that we have positional arguments to the call of the process, that this definition says that the process expects an argument, one single argument, when it is being called. So in this case, we have to define an argument here. We have to pass an argument, and the argument is going to be the output that we have defined for the process say hello. So we can write it like this, say hello dot out. That is probably the most important thing you need to capture right now, because that is what makes the workflow work and what connects in a dependency order the process say hello with the process convert to upper. We have defined the input of convert to upper as the output of say hello. So until the output of say hello has been generated, the process, the execution of convert to upper is not going to be triggered. This simple definition is what creates the order of execution between say hello and convert to upper. If there wasn't this dependency, the two tasks would have been executed independently and, if the system allowed, in parallel, because there wasn't any obstacle that would say execute convert to upper before or after say hello. So this is crucial, and you see that just by creating a dependency between the two, because the input of this one is the output created by this one here, the workflow is being defined in the order that is going to be run. Okay, now we save. We can run the code again just by using resume. And like we've seen before, this is the power of resume. It works when you debug the code, but it works also when you build the code. Because the output of say hello, we haven't changed anything in the code of this process. The output is exactly the same. The files that are being created are exactly the same. So in this case, if I write -resume, you see that the first process has not been executed again. We don't waste computational resources by running again some tasks. We simply build from that moment onwards. And now here we have convert to upper that's been executed. And under our results, we have these upper files with upper, bonjour, and so on. So I stopped for a moment here because this is really a crucial element. You can appreciate so many things from this very simple change we made. And I'm going to repeat these concepts here because they are really they are really important. So number one, we have defined a new process and we have added to the process definition the minimal elements that we needed: an input, an output, the script that defines the code we want to execute. And then we also decided that we want to publish the results of these execution into the folder that we named results. Second thing, we have automatically created a dependency order between the first process and the second process by defining the input of the second process being the output of the first one. This automatically creates a dependency, and it forces or it instructs the workflow to execute the two processes in order. This way, the channel that is the output of say hello becomes the input of convert to upper, and only when a data package flows through that channel, so it's shuttled from the process say hello to the process convert to upper, the convert to upper can actually be executed. Okay? Third, which we've seen before, is the resume part. When we use resume, the workflow, by using what has been saved under the work folder, knows that say hello has been completed already, no changes have been made to the code of the process, so the file is exactly the output file that is expected, is exactly what already exists. These tasks here are not executed again. So the workflow resumes from that point onwards. Now, let's have a look at something more. For example, here we have the one of the processes of convert to upper that have been written into work 3C, and then we have 432, and we look into this folder here. Now, you will notice one other important element of how Nextflow executes the work. There is no duplication of valuable disk space here. So what you see here is that this is a symbolic link. A symbolic link means that the file is not being copied, but this is simply a link to another file that exists under this other directory, which was the directory where the say hello task was executed for the file hola. So by doing this, we can see a couple of things. Number one, the execution is not copying files around in the disk, unless we have specified, like here, that we want to copy the results in the results folder. But all files that might be intermediate files or simply during the execution, they are not copied around, but they use symbolic links in order to point to each other. Second, we can see here, this is the folder where the execution of convert to upper for the HOLA is run. And then we can see everything here. We have the symbolic link, which is the input file. The code of convert to upper expects this file, as you can see here, existing in the folder where the code is being executed. And this symbolic link allows the execution to be written in this way. There is no path here, so that means that the file must exist where the command is run, and this is precisely what is happening. You can see it here, because by using the symbolic link, this file exists in the folder where command.sh is being executed, and therefore the command can be executed correctly. This is only possible because we have defined the input as a path. So everything that has been defined as a path is symbolic linked into the folder where this process is going to be run. So this specific task, of course. Okay, so this is the reason why when we go back into our folder and we go to the results, now we have copied all these new files into this specific directory. Okay, so now you know how to add a second step that takes the output of the first one and processes the output of the first step. So we can make it, if you want, more complicated. And we can add a third step where, for example, we might want to collect all these greetings and put them together in a single place, for example. So as usual, we can attempt and do this at the screen first. So we test the code that we want to add into our process. So here you should also get another take-home message as a method of developing code, which is also important. Before I actually go here, write the process definition, define in the script what I want to do, in simple terms, normally I have to test what I'm going to write in here. Right? So in this very simple tutorial, we test our code in the terminal. In more complex situations, you might need to run a specific software. So you want to run the code or test the code for that specific software first. For example, you want to align some reads to a genome, you want to test your BWA code before putting it to a process definition. Okay, so let's make the example of having 3 files with the upper code that might be the results of these here. We could do it from scratch. So we could, for example, echo our hello and then pipe it to tr again. Then I'm going to copy paste these so I don't have to write it 3 times. Then these. A capital to Z capital, and then we redirect these into upper hello txt. Then we want to do exactly the same but with bonjour. And then we want to do the same with hola. So we have these, and then we have the other ones as well, right? Okay, just pointing through. So if we wanted to collect everything, for example, we could simply cut the 3 files together. So that would be hello, bonjour, and then hola. And then we can simply put it into, redirect into a file which could be called, for example, collected, or let's write it in the capital so we stay with the same notation, collected dot output dot txt. Okay. You see, so this is the result that you can see. So this is what we want to achieve. So we can transport these tests that we have run into the new process that we want to write. So let's do it right now. So we write it here. So now the process is exactly the same as before. So we start by typing the keyword process, maybe spelled correctly. And then we call it collect greetings, for example. Another thing that you will notice here is that I'm taking the liberty of using some conventions, right? For example, I wrote the first letter, which is lowercase, and then when you use let's say multiple words in the same name or function name, usually the second letter is a capital one. This is something that, if you haven't seen before, is a common way of writing function names that is very common in Java, in Python, and so on. So I'm just taking the liberty to do this automatically, but if someone has a doubt of why I'm using this specific notation, this is why. It's just a habit, but it's not a rule. This just to clarify that when I do something like this, is not because it is a rule. And in fact, for example, in the community of NF Core, we have agreed that the definition of the processes is in capital letters, for example. So there's definitely no rule, and it's simply a convention that we sort of converge on. So let's start by writing published here. Sometimes these terminal swaps words. Okay, published here. And then again, results. And then mode is going to be copy. And this is nothing new, right? And publish here. Better. Okay, then input. And we're going to leave these blank for a moment. So I'm just going to put 3 question marks here because I want to discuss this part in a second, okay? Now, the output, we know this already because we said that we want a file that is called collected-output.txt. This is going to be hard-coded, so all warnings that we discussed earlier apply, okay? Now we have our script. And now the point is we have to define this part, and we know that we want our output to go into collected output.txt. Okay. So we have to define what we have put in here, okay? So ideally, if we look at what we have done here in the terminal, we would like our cat command to consider or to process all the files that have been generated by the process convert to upper, okay? So for sure, in this part here, this is going to be a type path because what the channel should shuttle from convert to upper to collect greetings is for sure of path type or file type, because that's what the output is, right? So we can decide to define, again, the value of where we are going to store this information into a variable that is going to be called input files. At this point, this is going to be relatively easy in the sense that if within or inside this variable here, we are storing 3 or 4 or more file names, then this part of the code is basically identical to what we have done in the terminal, right? So if we write cat and then we write the variable, like this, or we could write it without the double quotes because it's a variable expansion anyway, okay? Now we would simply have, I'll write it without the double quotes, but like someone asked in the chat, there is only the difference between strong quotes and weak quotes. These are weak quotes, so there's a variable expansion in there. So that's basically what is happening. This corresponds to this one here if inside the variable input files, we managed to put all the files that have been generated by converted to upper. Okay, is everybody on the same page? I'm just checking if there is any hand raised on the question on the chat. So if everybody is at the same step that I am right now, we simply tried to transport what we tested on the terminal inside the definition of the process. So this part should be relatively standard. So we created the publish directory directive. We wrote our input and output definition. We assume in our input that here we are going to pass the name and the file that we have created with convert to upper, and therefore this code here is simply a consequence, because if inside the input files we have the files like we wrote them in the terminal, this code is going to be equivalent. Okay? So now the important thing is to check how we can do this into the workflow, how we can translate this part into the workflow. The process definition is okay as it is, because we simply translated what we had in the terminal in the definition of the process, and this relies on the assumption, which we're going to test right now, that this variable will contain all the files that have been generated by convert to upper. So if that is correct, then we just have to add this step to the workflow, that is collect all the greetings into one single file, and then we just need to call collect greetings, and exactly like we did before, we have to pass as an input the output of this. Okay, so again, just to clarify, number one, this process here is going to expect one input of type path. So inside the parentheses, we have to give one argument to the call of this process. Number two, by using the output of this process here as an input for this process here, this is establishing a dependency between collect greetings and convert to upper, where collect greetings can only be triggered when the output of convert to upper is being produced. Okay? So this is the assumption, and if we have written the workflow correctly, then we just need to run Nextflow hello workflow, and then Nextflow run, of course. And then we resume. Okay, now probably we have a problem here. And we could see the problem right into the execution. Because just by looking at the terminal here, I can see that the process collect greetings has been executed 3 times. So for this process definition, there were 3 tasks. This is not exactly what we wanted to achieve, right? So we wanted to collect all the tasks, all the output of these convert to upper, and put them into a single file. So what I would have been expecting if the code or what I did was correct would have been a single task here for this process, not 3 tasks. The reason is relatively simple. The channel that this process here is creating will shuttle 3 different files, right? So since there are 3 elements that are flowing into the output channel, there will be 3 elements that will flow from convert to upper into collect greetings when I do something like this. And therefore, 3 elements means that the process is going to be triggered 3 times, resulting in the execution of 3 tasks. But that's not what I wanted to achieve. And I can see it here because, in fact, there's only one of the files that is going to be written here, especially because the process is a cat with a single redirection, so there's no append here. So whatever is written last is going to overwrite the content of this file. Okay? Right. Okay. So now we need to change these. What are we going to do in order to make sure that the process is executed as we want? There is another operator which, with some obvious naming, is called collect. The operator collect simply collects all the elements that are flowing into a channel and emits these elements as a single emission. So all the content goes from convert to upper into collect greetings in one go. This is done simply by adding the function, the operator collect here, after the out. So I'm taking the output of convert to upper, and like Marcel showed in the previous section, we are processing the channel through this operator that is collect. Collect takes all the elements that are flowing through the channel output of convert to upper, packs them together, and emits them as a single element instead of, in this specific case, 3 separate elements. Okay? So just by doing these, we simply pack everything together and collect greetings with only receive one input, and therefore will be executed one single time. We can also help ourselves. If you remember the example that Marcel has shown in the x.nf, so what we did in here, we could use the operator view to help ourselves and spell out some of the content of the channel. This, of course, works when you don't have too much content to print at screen. So I'm writing a couple of these, and I'm taking, for example, these convert to upper, and I'm doing these, and I'm using view without the collect. So with the curly parentheses, I can execute code in the call. So this is going to be for collection. This is going to be it. Jesus, okay. Right. So remember what Marcel has said before. When you execute an operator in this way and you make a call executing some code, the internal variable $it identifies the element that the channel is streaming at that moment. Okay. And then we can also do the same if we do convert out view, but I'm just going to copy paste, but as you can see, I'm going to put the operator collect in between out and view, and then I'm writing after collection. Okay. Now we can run these again and again with the resume. Right, and now we can see that everything happened as we wanted. So this process here has been executed only one time, which is exactly what we wanted to achieve. And then we have inspected the content of this channel here. Like we said, with $it, we are viewing the element being emitted by the channel at that moment. So if the channel contains 3 elements, this code here is executed 3 times, and we can see that the emission goes in this way: upper bonjour, upper hello, upper hola. If in between we run the operator collect, then we can see that the channel completely changes and it becomes a list that you can see here, which is preceded by square parentheses, pretty much like in Python, you would say. And then this list here contains all the 3 elements that before were emitted separately, one by the channel. Okay? So again, a couple of things to observe. Number 1, we've added a process definition here in the same way we've done before. So this is the method of coding you will bring home tonight. You start by writing a new process, keyword process, name of your choice for the process, understandable possibly, and then minimal definition, input, output, and script. Best way to move forward, you have tested the code you want to run in the process before, so you know what to write in this section here. So this should be something you're familiar with. If you want to write a process that executes a software of your choice, you should know that software. It has nothing to do with Nextflow, okay? This part here is simply the execution of the code of your choice, which you want to organize or orchestrate in a pipeline. Once you've done that, then you start shaping your workflow. And like we see here, the shape of the workflow is very simple because you execute one by one the processes that you have defined. And then the way the workflow is orchestrated is automatically defined by the dependencies that are established when you connect the output channel of a process as being the input channel of another process. Then whatever flows as a data package through that channel from one process to the other one defines what is being triggered. Very important is also that we can modify, shape, change the content of a channel by using an operator. And we have seen a couple. An example we have seen in here with the map function that simply applies a function to an element that flows into that channel. In this specific case, there isn't really a function. It's simply just the selection of the first element of that object, of that list in this case. In this case here, the operator actually changes the shape, if you want, of a channel in the sense that instead of emitting elements one by one, it emits all the elements that have been put into the channel by the process convert to upper together and then emits them all at once. And we can see it very clearly if we simply run a view operator on the results of this. Okay. So if this is clear and there aren't any specific question on this part or doubts or things that you find a little bit more difficult to understand, we can move forward to another important part, which is, let's imagine that we pass more than one input to the process. Okay, so for example, in this final process here, like I highlighted it immediately in the very beginning, because this is, if you want, is not really a good practice, is to hard code the names of the files. In the same way, we changed how we write these by making these file names as a variable. This is somehow what we should do in here, because we don't want to hard code stuff into our code because it doesn't make it flexible, it doesn't make it reusable. So it's a little bit against the logic of adopting Nextflow to port your code from one place to another, right? And then you have hard coded all the file names. That's not exactly what you want to do. So if we want to imagine that, for example, we want to call this output file in a variable way, we need to add a variable. So the variable must be collected as an input, and this could be a value, and we could call it, for example, batch name, meaning that every time we're going to run the code, the workflow, we will pass a batch name as a variable, and then this name here can change. So, for example, we can change it using the variable batch name here. So we could call it collected, and then we could add dollar . The cursor sometimes jumps from one place to another. Batch name here. So this is going to be our expected output, and therefore it must be our expected, our created output here. Okay. So now we are writing the result of the command cat into a file that's called collected dash a name that is going to be variable and that has to be given to the process execution, and then dash output.txt. Now that means that we need to pass these somehow in the parameters. So in order to do that is again a good practice to define a default value. So this is going to be batch. And this could be, for example, our test batch. Okay. So now that means that we can either use the default value or pass, if you remember, these parameter at command line using, for example, dash dash batch. But we also need to change these because now we have changed the process definition, and now this process here expects 2 arguments when it's going to be called. So one argument is the collected output of the channel coming from convert to upper, and then the second has to be, for example, params dot batch. Important element again to stress. We mentioned that the parameters given at the execution, they don't necessarily need to be in a specific order because they are named parameters. However, the inputs of a process are not named inputs. So they must be provided in the same order, exact same order, as they have been defined into the input block. Okay? So here, when I call collect greetings, now I must provide first an argument of type path, and then an argument of type value in the very same order as I have defined them. So the first one must be what I'm going to use as file names, and the second must be what I'm going to use as variable name for naming the output. Okay? So if that is all correct, now we could rerun Nextflow run hello workflow, and then we want to resume, and then we want to pass the batch name, and we could call it, for example, trio. Right, now this is correct, and now we look at our results, and we can see here that we have a file that's called collected trio output.txt that contains the content that we actually expected. Okay. Okay. This is not the end of this part here, because there is another thing that we could we might want to do, for example, which could be, for example, count how many greetings we have, because we have called it with a, for example, a batch with a batch name here, and we might want to change this part, for example. This is a demonstration, of course, just to show how we can use other things to make the process a little bit more complex. Okay. All right. So, for example, in the script part of these, we could decide that we suddenly want to change our batch name, and we want to do, for example, count the greetings. Okay, so for example, we could count the greetings here that are given by the number of files in the input. So in the script part here, we can execute some Groovy code. This could be, say, count greetings, for example, equals input files dot size. Okay. So an important thing to notice here, we have 3 double quotes. This part here is the code that is going to be executed as the execution of the process. So that's the operation that is going to be run in the environment where the process is executed. So this is a bash code. The code that we have put outside the 3 double quotes instead is going to be computed at runtime. So when we pass input files, the input file variable exists, will contain the value that are passed when the process is actually called, and this is going to be computed. Okay. Right. So we could do a couple of things here. We could try and, for example, use this variable in different ways, and you could use it as an output as well. So, for example, an important thing we can change here would be the emission. So, for example, we can name the output of this process. This is done by using this additional call here, for example, that is called emit. So when we do something like this, you see I've added a comma, space, emit, colon, out file. So now instead of having one single output, and I'm taking this output simply by writing .out, now this output has a name that is called out file. This is going to be very handy if I want to output multiple things. So for example, let's imagine that I want to output the variable that I have computed, this one here, right? And I want to output this variable and give it a name, which is count. Then if I want to be very, very nerdy, I could use what's called partial alignment, but this simply gives a bit of an order to the way we write the code. Okay. So now you can notice a couple of things here. Number one, I'm not going to define the output as they are, but I'm going to give a name to the output. Number two, this is very convenient because now I have 2 outputs. So I can distinguish the 2 output channels by using their name. Okay. And I can use this part here, for example, by creating an additional thing here where I'm going to view the content of one of the output. So let's remove this part here, which could be inconvenient. So this is useful just to print a message at screen, for example, that shows how many greetings I have actually collected into this process. So in order to do that, I'm going to capture the output of these. But now in the output of this process, I have 2 channels. So I can, since I named it, I can capture the channel count and view specifically this channel here. This is only possible because I named the channel. Okay, so now I could say, for example, that in this batch there were $it greetings. Okay. Again, you will see a couple of things. So we have used number one, the count operator here. Sorry, the count name in order to capture specifically one of the two output channels of this process. Number two, we use this to print a message screen that reports the number of files that have actually been run. So now I can run exactly the same thing. And you can see that in the message here, I get printed in this batch, there were 3 greetings. Okay? So before concluding this third part, let me stress again what we have seen until now. Okay? So number one, we have added another process, a third one, and therefore we have called for a third process in the workflow. Number two, we want this process to have 2 different inputs. And therefore, when we call the process in the workflow, we need to give 2 arguments to the call of this process in the very same order that we have defined them into the input blocks of the process definition. They have to be exactly the same. Number 2, the goal we wanted to achieve with this specific process was to collect together all the results, all the outputs of this process here. So it's not sufficient to pass just the channel emitted by convert to upper as a result of this, because we needed to pass a single emission. Otherwise, if we pass 3 elements, the process is executed 3 times, resulting in 3 tasks. We want these to be executed only once because it has to collect all the outputs of the previous process and put them together into a single file. So we need to use the operator collect in order to reshape the content of the channel resulting from convert to upper, and packing together in a single emission all the elements that are flowing through the output channel of convert to upper. Okay. Then we've done something more, which is changing also the output and making sure that there are 2 outputs from this collected greetings process. Now, once we have 2 outputs, it is convenient to name the outputs channel for the process so we can distinguish and therefore capture one or another if we need it. And in fact, this is exactly what we have done here. If we wanted to simply print at screen the content of the second output channel, which is simply the count of how many files we had as an input, then we can do it by naming the count channel and calling for the count channel. Here you have to notice the hierarchy, right? So the count channel exists under the hierarchy of the outputs that have been defined in the process definition of collect greetings. Okay, it's actually pretty easy if you think about it, because it is collect greetings. From collect greetings we get the out, which is the output channel, and from the output channels in this case we get count. So this is how you get to the code here. So collect greetings dot out, these access the output blocks, and then in the output blocks we get count, which is the channel that contains the variable that we calculated. Okay, this is what I needed to say for this part. I will leave the floor again to Marcel. for the fourth part of the modules.
Everyone, I'm back for part 4. And before going to the training material, I just wanted to introduce the reasoning behind modules, right? So with Francesco, you saw now a relatively long pipeline based to what you saw at the beginning of the training. So we have 3 processes now. We have a workflow block with a reasonable number of process calls and operators being used, but still, this is a bit far away from, like, let's say, real pipelines that are usually very large, right? Let me show you one example here. Here we have the NF-core RNA-seq pipeline. It's a very famous NF-core pipeline. It's not a very long one, but still, as you can see here, every white circle is a different software. So it's usually one or more processes in the pipeline. So it's very long, a very large number of processes. We have dynamic are taken during the running of the pipeline. Sometimes it goes 1, 2, 4, 5, or 1, 3, or and so on, right? Or 1, 2, 4. So it can become much more complex than that. And still, again, just with what we've shown you so far, these 3 processes, it's already a long file. It has almost 100 lines, right? So let's say that you want, there's some error, and you want to investigate in this file where the error is. It's not so easy, right? It's already a long line. It could be in one of the processes. It could be maybe in the parameters. It could be in the workflow block, in some of the operators. It's hard to say just by looking because there are so many different things, right? So the idea of modules that was introduced in Nextflow a few years ago, the idea of modules is to encapsulate some part of your pipeline so that they are in another file with everything they need, so that when you want to debug, to investigate what's going wrong in your pipeline, you can go to the modules files to see if it's a module issue, or you can go to the main.nf, the main script file, to see if it's a workflow block or not, or you can go to the configuration files. So there are many different files that are already detached from the main script file, but the processes, they weren't until recently, until a few years ago, right? So the modules is this attempt to make sure things are organized in a nice way so that it's easy for you to investigate what's going wrong. Depending on your experience with software engineering, there's one thing called software testing, and we also have unit testing and automated tests, right? So the goal is to make it easy for us to test our software, that it's working as expected. By having these modules, you can have software like NF-test is a software to test in Nextflow pipelines. So you can have NF-test, for example, to test only the modules or only the pipeline or some modules. You can have things being tested independently. That makes much easier to write these tests, right? So if you want to see if one step of your pipeline is working well, it's very easy. But if you want to do a test that tests 30 different processes, things can get very complex, right? So testing software, debugging, like investigating errors in your pipelines is much easier when you have your processes organized as independent modules. Collaborative work is also much better because if you are working with colleagues on the same pipeline and you are working on one module specifically, I'm working on another one, so we are using different files, it's very clear to us what is part of each module. Here, for example, I have this section with all these pipeline parameters. When it comes to NF-core pipelines, you could have a lot of parameters. We can go here to the section parameters for the RNA-seq pipeline, and here you have some. But there are even hidden parameters. So it could be like dozens, of parameters. And if you're not using modules, they're all going to be listed here. And then when we are studying this pipeline or investigating this pipeline, the question is, this params.batch, where does it go? What part of the pipeline, what module, what part of the workflow do I have to pay attention to see what's being done with this params.batch, right? When you have your pipeline with modules, you can go to the module file and you know what's the parameters for that module, some specific configuration, the process calls, all the information, the tests, everything, test data, everything specific about that process, about that module, it's going to be in the same folder. So it's much easier to learn what the pipeline is doing, to investigate, to do collaborative work, and so on. So I hope that by this point, I convinced you how useful it is to work with modularize your pipeline. Another example is that maybe you finish this pipeline, as you can see here, and then you're working with someone, and a colleague says, you know, this convert to upper process that you use, it's very nice and it's very useful, and I would like to use this in my pipeline. Well, the person would have to come to your source code. They would have to have access to your entire pipeline, which sometimes is not possible. Maybe it's a proprietary pipeline, or it's you can show the code to anyone else, right? In this case, either you would have to cut it for him, or he would have to come and access your code, copy paste this, for example. But it's not that easy, because maybe there's a parameter you need, and he would have to read the whole code to make sure that he knows everything he needs to run this process, and then copy paste all these things to his pipeline. And then he'll be able to use this for you. But if you modularize this, it's much easier. But how does it work? So now let's modularize this first step, this first process, say hello. Let's turn it into a module. The first thing is that we're going to create a modules folder, right? So here we're going to create this new folder called modules, and our modules, they're going to be inside this folder, okay? So let's create this file inside the modules folder called say hello. It's a good practice to name the main script file for the module the same name as the process name. So here it's say hello, so say hello.nf. I'm going to create this file here, and I'm going to copy paste this. And then I'm going to remove that from here, right? So with this, now I have a single file, say hello.nf, that has the process block, right? But how does the main script file knows where this module is, right? So usually we do it before the work, right before the workflow block. I'm going to say here, include the module name, which is say hello, from, and then I'm going to say modules say hello.nf. Just by doing that, this should work. So first time I am running this, if Francesco was running this code, you would get the cached runs because he already ran this code in the part 3 with you. But because the first time I'm doing it here in my different virtual machine, everything was done from scratch. But as you can see, everything worked, even though a big chunk of code disappeared here. But I'm including it back here, right? Let's do the same thing now with another module. One thing we could also do, and I mean, when it's simple, it's easy to do these things, but when it gets more complicated with a large number of modules, you could have different folders for each one. So for example, if you go here to the NF Core modules, NF Core is a project, as I said at the beginning, right? We have best standards and pipelines and assets. For modules, we have almost 1,500 modules ready for you to include in your pipeline. There's a program, a software called NF Core Tools, and you basically say NF Core modules install the name of a module, and it automatically gets inside your pipeline, right? So here we have almost 1,500. And if you go to the NF Core modules GitHub repository, you're going to see that they have a modules folder, just like we did, but inside it, they have the folders, and of course, they have the folders for each module instead of the file. And the reason for that, let me see what was recently changed. The reason for that is because here they not only have the script file that you're using, but they also have some meta YAML file, some description about the pipeline, some information about creating maybe conda environments, files and scripts for testing. So as you make it more professional, there are a lot of things you want to do about your module. So they create a folder for each module, right? Differently from us here, that we just have a script, so just the file, and then it's fine to do it this way, right? Let's do the same thing for the second process. We're going to copy paste, cut it from here, right? And again, we're gonna include convert to upper from modules, convert to, oops, I see there's an N missing here, upper.nf. And again, just by doing that, it should work. The funny thing is that by using the resume option, which is to Nextflow take advantage of what was already run before, we can see that everything's cached, even though I took a big chunk of code and moved it somewhere else. The reason for that is because nothing really changed. It's just the location of the code, but I didn't change the script. If I change something here, then I would lose this cache because something changed in the code, right? And then let's do the same thing for the third process, which is collect greetings. So code modules collect greetings.nf. I'm gonna paste it here, and we're gonna include just like the others. Include collect greetings from modules collect greetings.nf. Let's run it again with dash resume. And here we go. Everything is cached. Nothing changed. Everything was modularized just fine. Here we are creating, again, modules. But the modularization in Nextflow, it goes beyond just modules. If you go to the NF Core website, for example, and you go to resources, you're going to see modules, but you're also going to see workflows, which means I don't think that one module alone, I mean, it could be useful, but these three modules together, they are also useful. They have a reasoning that makes sense. So I can get them together in a sub workflow, and I can share this. We call it module, but we call it a sub workflow, but it's also a module, right? It's not a process module, but it's a modularized sub workflow. And you can share this, and anyone can use this, import it in your code, right? You may be confused a bit on why I'm showing NF Core so much. Is all the pipelines here or the modules here? No. The thing is, NF Core does a great job of curating all these assets, these modules, pipelines, and sub workflows. They're very high quality, and they host it, and they are sponsored by companies like Microsoft and Amazon and Sequera and so many other companies to keep testing there so that we have a high quality repository of all these things. But you could have your module repository. There are multiple institutions around the world, public and private, that they have their own registry of Nextflow modules. And if they're public, you can just download the module file, include it here in your pipeline like I'm doing, and you're ready to go. And the good thing about this is that depending on the software that you use, you just come here to resources, go to modules, you see all the modules that are available, and depending on what you want to do, you don't even have to write any module because they're all here. You just keep installing the modules, like downloading the files. You include all of them. You write the workflow block, just saying what order you want to do, where the data is coming from, and you have a ready Nextflow pipeline without having to write a single step. And this is not only about writing step, right? It's not about just time-saved typing. Actually, these modules, they are very well built. Here, based on the basic knowledge that we have so far, if we go to these modules, we basically have input, what's getting in, what's getting out, some simple command of what's being done, and here we also use published here. But if you go to a real module, like a professional module, let's say, it's much more complex than that. Let's look at this lead counter, for example. Look at the size of this file. And what's being done, the real code, is just this. It's just this. And actually, this could be one line. It's split here in multiple lines to make it easier to read, but it's one line. Everything else is a lot of expertise that was added here. The person that created this module, they know how to use this software. They know the amount of resources that is needed to run this software, right? So when you run this on the cloud or an HPC, you don't have to worry about the resources because it's already here, the information of the amount of memory and CPU and disk size and time for processing. Everything is already encapsulated in this file by this process load label here, right? working with the NF core tools. So this means that just this line here already has so much information. And if you want to run your pipeline with Conda, creating Conda environments and using Conda to do the package management, is already here, the environment YAML file. If we go back here to the environment YAML file, you're going to see all the packages and versions and channels and everything else from Conda to install this. Not only that, if you want to work with containers, Docker containers, for example, you can go back to this main.nf. Here it shows where to get this Docker container, the container image. If you're using other container technology, like OpStack, for example, it doesn't matter. It's going to download this container image. If you want to use Singularity, here is the path to a Singularity container image. Here it has the best way of receiving data, outputting data. It saves in a file the version of the software. There's meta information about each sample. You can pass optional parameters. So it's so much, and I cannot get into much detail because it can get very complex here, like these extra arguments. But what I want to show you is that by using modules that others did, it's not only about saving time typing. There's a lot of expertise, expert knowledge here in this file that you don't have to worry because it's already done for you. You just have to import, run it, and it's going to be amazing, right? So the feature of Nextflow of having these modules is really amazing. And the fact that NF Core provides you with almost 1,500 modules out of the box is even better, right? Another thing that I wanted to show here very quickly is Secure AI. Like if you have some questions, you can come here for free. It's like a ChatGPT, but specialized for Nextflow, and you can just ask. So before I asked, for example, why using modules in Nextflow? And it gave me so many different reasons. But you can do actually much more than that. It's a very powerful tool. After this training, if you have questions, you can always go to the community forum, which is community.secera.io, right? And you're going to have a forum of people with questions. You can ask questions and answer questions and so on. But Secure AI is also very useful. And I recommend you to not only ask questions there, but ask questions like the one I did, not technical questions, but why modularize? Why use single quotes or double quotes, which is a question that I saw here. All these questions, they can be asked there. And because it's an AI specialized in Nextflow, it will give you very specific and precise answers, right? So as I said, there's the NF Core tools, which is a very powerful tool to manage these modules and pipelines, but it just goes out of the scope of the training today to learn how to use this tool. So for now, the goal is to make sure you understand the reasoning behind modules, why modules are important, and how to modularize your pipeline. So before we had almost 100 lines, right? And now we have, it fits in one screen almost, right? The parameters, the includes, and the workflow block here. It's much easier to do. And as I said at the beginning, that these colors that we have, the red color and so on, they are all colors by the VS Code extension that we have for Nextflow, which is the Nextflow language server. If you put your cursor on top of an include process, or even here when you have the process being called, it will automatically go to the file and tell you what's the input and output of the block, which means that you don't have to go to the file, read, come back, and all these things. You can just go here, see what's the input, which is an input file, what's the output, which is a path, and you don't have to go there, right? If you press Control or Command and click on it, you can go straight to the file, right? So even though you are splitting the content in different files, you can very easily access this information with the Nextflow language server on VS Code. Another interesting thing, I'm not sure if you saw, but above the workflow block here, you have this preview DAG button. If you click here, it's going to create a directed acyclic graph, a DAG of your pipeline. And here we see what's happening. We have the greeting parameter, which is passed to the say hello function process. The output of the say hello process is the input to convert to upper. In the input of collect greetings, it's both the output of convert to upper, but also the batch parameter. Here it's a very simple, again, it's a very simple pipeline, but you can see that as it gets complex, it's very nice to have this visualization of the interaction between all these modules and parameters and sub workflows and so on, right? And you can also copy as Markdown. You can export this as an SVG or HTML. So there are many different features that you have on VS Code, writing code for Nextflow, right? With that, I think that's all. Yeah, that's all for this part, for the module part. If there are any questions that arose during the presentation, if you want to ask any question, it would be great. I'll be happy to answer. Any question, any comment, anything Francesco may want to add about modules?
No, I think, Marcel, you covered everything important and also stressed probably the most important element of having modules. I think in general, for those who are learning also how to maintain their code, and it depends very much on the audience of today's tutorial. One reason is definitely reuse, and I think this is very important nowadays, that we all stress on the importance of recycling. That also works with code. And if you think about an eco-friendly way of thinking about code, developing is also expensive. When you want to develop a module, you have to test your code, run, debug. This consumes computational resources and produces CO2. So the idea of reusing modules that someone else has tested, written, debugged is not just taking someone that is ready or how convenient it is. There's an impact of developing code. So if there is a community like an F-Core who's gone through the trouble of discussing what the best practices for some software are, putting this stuff into modules and making them available to everybody else, it's not just about deciding how the software should be run. It's also saving other people of the trouble, the costs, and also the impact on everybody else, environment included, of developing the code. So I think this is really a very beautiful thing. And then the second is a method, in the sense that obviously when you have modularized your work, but this also works in Python, or in other languages, it becomes incredibly easier to maintain, because then you don't have to go through thousands of lines of code for finding a specific error or changing one little thing because you have updated the software that runs that specific part. You only have to go through the module that executes that piece of your pipeline and then update that one to the new software or to the new command line when a software gets updated. So there's this additional advantage of maintenance, which, like Nextflow does in many other things, it also makes maintaining your code and keep developing easier in the long run. So it's a small investment in the immediate future, but a very important investment in the long term.
Definitely. Just a curiosity, we have an Nextflow plugin called NF CO2 Footprint, right? Which is very good. You can run your pipeline with this plugin, and it's going to say what's the CO2 impact of your pipeline and where you can do better and so on. So it's a very nice plugin if you want to see what's the impact and how you can decrease the impact of your pipeline run. So you're going to run this pipeline sometimes thousands of times, right? So even if you decrease by 1% the impact, it's going to be large in the long run.
Yeah, exactly. And there was a very nice presentation of from Loic in Barcelona, showcasing how this is used. All right, so let's move to the next part, which is all about containers. So you should see my screen right now. I'm going to disable my video again. Okay, cool. So now we mentioned so many times software. Until now, in all the examples that that we have seen, we've only run bash commands. So clearly we didn't need any specialized software or any specialized application to run our processes. However, in the vast majority of the cases, you need some specialized software to be run in a specific step of your workflow. And since we stressed since the beginning the idea of portability, containers and portability go hand in hand, and therefore Nextflow goes hand in hand with the idea of containers. In this specific example, we will use Docker as a container technology, but Nextflow supports several other container technology as well. I'm mentioning here Singularity, Podman, there's a number, depending on the environment, the computational environment you have to run your pipelines on. So let's have a look at the workflow that we are going to be using today, which is the status of the workflow where Marcel has developed until now. So we have modules under a modules folder here. These are the ones that have been ported until now. And then we do have the includes into the main script that we are going to run. Now, if I followed Marcel's part correctly, I should have created all the modules at the same time, and they should run. We're going to see it right now because I'm going to test the workflow. Nextflow run hello containers, and that should run hopefully using the modules in the folder if I have put everything as supposed to be. Okay. Right, that confirms I followed Marcel's part as well while you were coding. So we can start from this step here and see what we want to do. So first of all, we said we're going to use Docker as a container technology, and I think in the very same approach that we have employed until now, before making any changes to our code, we want to test on the command line what we would like to put in the script block of our new modules in this specific case. So the idea here is to use an example container that is called CowPy. This is a silly, as funny, it depends on how nerdy you might be. It is a Python implementation of a tool that is called the CowSay that simply generates an ASCII art to display arbitrary text inputs in a fun way. So in order to do that, we need a container. One very handy tool is provided by Sequera. This is for free for everybody, for the community, possibly forever. It is a repository that holds containers that can be built on the fly using specific packages that are available either on PyPI, Bioconda, CondaForge, and other channels. If the package or the container has been built by someone else, the container is going to be already available in the community repository of Sequera containers. This is again to stress the recycling, reusability of things. So instead of building yourself new containers, the containers can either be built on the fly, or if someone has built it already with the very same packages that you want to use, they would be already available in the repository of Community Wave of Sequera containers. So this is a very good way, again, to save yourself from building new containers and again, wasting computational time. So let's do like this and search for CowPy. We want it, for example, on a Conda package instead of PyPI. So let's search for CowPy, and then we see that there is one in CondaForge. So we're going to use this package here to build the container. you can see that here you can build it either with Docker or Singularity. We're going to use Docker. You can build it for multiple platforms. We're going to use AMD 64, which is the one of the virtual machine we are running right now. And then you can see that if we get the container is ready. That means that someone else has already built it, so we can just copy the address, the URL for this container here, and simply reuse it in our environment. Okay. So like we said, first thing first, so we want to test on the command line how to use this container. The first thing that we need with Docker is running a Docker pool. So we simply pool in our environment. This Docker should be very lightweight. It contains a very light software. Normally, now that we have the container locally, when we want to run the container, we normally run, for example, Docker run, and then we use RM to say that the container has to be removed once it's been run. We use container name, and then normally you specify a tool command, for example, something like this. Okay, this is the general syntax, just to remind the participants what's the general syntax of using or running a specific tool that exists inside a container. Now, in our specific case here, we want to simply run a command through this Docker here. So it's going to be Docker run --rm, and then we want our community wave Docker here, and then we want to see the software cowpie. As you can see, this is the default. It will reproduce an output simply running the container with default parameters. Okay, we can run the container interactively if you want, just by adding the -it option to the container run. So it would be Docker run --rm. Again, this says that we want to remove the container once the run has finished. But this time we want to run it interactively and get a terminal out of it. So we're going to run this container, which we have downloaded already, but we're going to run bin bash. So by running bash, this will give us a shell that will allow us to access the container from the inside. So this is going to be a shell inside the container. Unless we run it with the -user command, this is going to be a root access. And then at the same time, we can use it, for example, to run a bash command like ls of the root folder, so we can see the file system of the container. Okay. Now, for example, if we were to run cowpie on I don't know, hello containers -c, and then we can choose the character we want to run the command on. Tax is the character, but we can also change characters and and for example pick other characters. I don't know, for example, what we could pick, a turtle, for example, turtle. That would give us a turtle. Okay, so you can play with this as much as you want. Now this is okay, but of course we would like to use actually the greetings that we have in our greetings CSV. So first of all, we need to exit the container. And then in order to use the CSV, we need to let the container access the file of CSV. So in order to do that, we need to use an additional command in Docker, which is -v, which is a command that an option that is used to mount a volume and map this volume outside the container. What do I mean? The syntax is the following. So you run again docker run, and then you use the different options. In this case, we want to use -it again, but we want to map with -v the host path or outside path to the container path. Okay, so you could call it outside, inside, but I prefer to say host is the machine we are running right now. Container is the path inside that exists inside the container. So right now we want to do, for example, the current folder, and we want to map it into a folder inside the container that's called data. Then we want to use the container again, and we want to access a shell. So exactly like we did before, we run the command bin bash. Now, if we look inside data, you can see that since we mapped the current folder, which is everything here, under the data folder of the container, if we run ls/data, we see all the contents of our main hello Nextflow folder here. Okay. So now, if we want to use this folder and we want to use the greetings CSV, you can see that if we cut the content of that CSV, we could, for example, pipe this content to cowpy. And then we can use, for example, this time we can use the turkey. And now if we scroll, we can see that the turkey has this balloon saying hello, bonjour, hola. That's our test. So we basically tested that if we enter the container, we stream the greetings CSV to cowpy in this way, then we will print at screen a character of our choice with the balloon saying what we had in the greetings file. Okay. Now, a couple of things that we want to do. First, we want to use this software and therefore the container in a module. So the first thing we need to do is to create another module file exactly in the same way that we have done before. So first of all, we create an empty file under the modules folder that we call, for example, cowpy.nf. Then we can code it. And now this is going to be exactly like we have done before. So if we write things a little bit more professionally, we start with a shebang, which defines what kind of language is going to be used in the script that we're using. And instead of writing an executable of user bean, we can use the env, which is a little bit more error safe. So we can use, say, error and the Nextflow like this. And then we can start processing or writing our process definition. So use, for example, cowpy to generate this cursor jump is incredible. Generate asking art. Okay, and then this is going to be exactly like we've done before. This is just to showcase the helper that you have in VS Code when you run the Nextflow language server. Okay, I've just run a process and then I got a suggestion, and if I simply hit enter, then I basically get a helper which gives me the structure that I'm supposed to use, okay, in a slightly more professional way. I will delete these because doing the hard work and coding everything from scratch helps us remember the key elements that we want to code on, okay? So exactly like we have done for the other modules, we start with the published here, and then this is going to be published under results, and then the mode is going to be copy. Then we have the input. Now here we want a couple of things, because we have seen that when we test the code here, we can use cowpy with two arguments actually, right? So we decided, for example, that we can have a specific text, but we can also choose the character. So we might want to be flexible and do both in our module. So we choose with the path the input file that we want to contain the text that has to be outputted in the balloon. And then we also want a value that is going to hold the character name. This way we can run the code of cowpy exactly in the very same way we've run it until now. So that's going to be all for the input. Now we need the output. The output is going to be a path where we put, for example, the cowpy file result, okay? We're going to do this in a flexible way. Now it should be established that we don't want to hard code inputs and outputs. So we are going to write the file name as yes, cowpy, but we're going to use a variable, and the variable is the name of the file that we have captured from the input here. So I'm going to use exactly this value here, and the output is going to be the very same name of input file that is received by the channel, by the process through the input channel, and is going to be emitted as an output where the expected name is going to be prepended by cowpy dash, and then again the name of the input file. Okay, now we have defined the single output channel. We can write our script. 3 double quotes to begin, 3 double quotes to end, and then here we just have tested already the code, right? So we have cut the name of the file that contains all our collected greetings. Then we have cowpy, the name of the character, and then we need to stream it or to redirect it to the expected output file. So this is going to be cut. Then we already have the variable from the input file here, and we just follow. You see, again, I'm going to stress the code that we're writing here in the module is not something we have to come up with from we don't know where. We know what software we're going to use. Hopefully, we already have used the software before. We know how it works. We know what kind of arguments the software is going to expect. And even better, we have tested the code we want to write in the module script in another environment to make sure that the code is going to work. So here we don't have to come up with anything. We have already tested the code, which is cut the name of the file. That's what we're doing here now. Pipe, and then we're going to write cowpy. -c, that's going to be the name of the character, and the name of the character is going to be our variable here, which is called character, right? Okay, and then we output, redirecting these into a file that is called, again, we can simply copy paste these so we don't make any mistake. And then we have our code. Okay, now we can work on the hello containers, and we need a couple of things. Number one, we need to add and include. This is the same thing we have done before, so there's nothing really new here. Include. Then we want to include this one, and we want to include cowpie. Now, one important thing that I'm going to stress again, which Marcel has pointed to already, but repetita iuvant, as we say, repeating helps. The name that we write here needs to exist in the file that we point to with from, okay? You can give it another name if you want. I'm not going to show how right now. But if you don't specify another name, the first name anyway here must be found in the code of this. So since we called this process cowpie exactly like this, no capital letters, here we need to use cowpie. Okay? Then we have from, and then we have in modules, and then the file is called cowpie.nf. And now we can actually reuse this in our workflow. Okay? Okay, now the only thing we need to do here is simply add, after this one, another execution that actually calls for the process. Okay, so now we do generate ASCII art with cowpie. And this is very simple because we just call for this one. You might notice my copy paste here because that's a good way not to make mistakes. And then you remember now that this one is a named emission, right? So let me write it here. Go to modules. And then we want to collect greetings. Now you remember that here we have a named emission for the output channel where we have the greetings collected. So here we need to use .out file. This is how we're going to get it. And then, again, I'm stressing this, but it's very important. We have defined cowpie process with two inputs. The first one being the file where the greetings are stored, the second one being the name of the character. So we want the first argument of this call to be the file, the second arguments to be, for example, a parameter of our pipeline where we're going to put the character. params.character, okay? Like we've done before, adding a parameter to our pipeline prompts to the need of defining a default value for this one. Okay, so we might want to define a default value, and we use the turkey here, was quite nice, so I'm going to use the turkey again, but you can change to whatever you like. Okay, so now we have defined the default value, we have connected, we have included the code of the module, and we have called cowpie, connecting the channel out file that is going out of collect greetings into the input of CowPy. This is all we need to make this work. And unless I forgot something around, this should be enough to run the code again. And we can run it again with the resume flag. Nextflow run hello containers dash resume. Okay, there is something that I have missed. So CowPy not found. Yes, exactly. Why the CowPy has not found? Because we stressed the container thing, right? So we needed the Docker container to find the software. This software, CowPy, does not exist in the environment we are running right now. And we can see it very easily because we are in the host right now. If I type CowPy, the command is not found. So the error that we are actually seeing here is precisely what we would expect, and the reason why we tested Docker in the first place. We don't have this software in our environment. We need a container in order to access and port and reuse a software that exists somewhere else. So we need to do something additional, which we haven't done. And that's the whole point that I want to see with you right now. So there is another directive that we can add into a process. So here I am again inside the process definition of the module CowPy that is called container. So I can write here container. This is a directive that allows me to specify that for this specific process, the software should be found by using this container here. So that's the container. And I want to put here the URL for that container. Okay? So now I've done a very important change to this module, to this process definition, which is adding a container directive which instructs Nextflow to run this process through the container. So not using the local environment where I'm running right now on the terminal, but use, like we've done before here, this software inside the container. That's a pretty important change because, like we see here, this command does not exist in our local execution environment. Okay, so that's one thing. But we also need to enable to tell Nextflow, to instruct Nextflow that Docker must be used because, like we said, Nextflow is very flexible, can use several container technologies, one of which is Docker. Okay, this instruction, and this is perhaps the very short introduction to the file that is called config, is given, for example, through a configuration file. So a default configuration file Nextflow is looking for in the same folder where our script is executed is called the nextflow.config. And this config file holds configuration settings. One configuration settings in this case is whether or not we want to enable a specific container technology. As you can see right now, the Docker is not enabled. So in order to make sure that Nextflow actually runs software through Docker when a container is specified, this could also be a Docker container, but we might run another technology which is able to convert the Docker container. So the two things are not necessarily codependent in the sense that you need to have a technology enabled. That technology should be able to use the container that you have specified here. That's all you need. In this case, we're going to run Docker, so we need to enable Docker, so we change false to true, and then now we can try again our software and do exactly the same. Right, and now we have, as you can see, a new file which is called the cowpie collected test. If we look at the file, this is precisely the execution that we ran before in the terminal. Okay, now let's try and understand a little bit more of the files that I have introduced you in the very beginning when I showed you the content of the work directory, which again, I really prompt you to look into, because that knowing the hierarchy of the files in there, knowing how to find the folder where a specific task has been executed is really instrumental, perhaps not in your daily life, but whenever you need to understand where a problem originates from or how things work, because sometimes Nextflow translates into the specific environment the instructions you've given into the module, and you want to see how those instructions were actually translated for the local environment. So this is exactly what we are looking at right now. Now, if you remember what I showed in the beginning, if we want to access the execution folder for this task, we know that this exists into the work folder in the structure 9D-F399. So we cd into work, then we go into 9D, and then it's going to be F399, and this is going to be unique. We go here, ls-la, so we can also print the hidden types, those that begins with a dot. And now again, I'm going to point you to a couple of things. Number one, exactly like we have seen before, Nextflow makes a heavy use of symbolic links, so it doesn't waste disk space. And at the same time, the file that is defined as a path data type in the input has to exist in the folder where the process is going to be executed. So this is made it possible by creating this symbolic link here. Now let's inspect the file command run, because we have seen before the file called command sh. The command sh is simply what we put into the script. You see, it just has a variable expansion. So this variable here has been expanded to its content, which corresponds to the input that the task was expecting to receive. And then also the variable character and these one have been expanded in order to match the specific execution of this task. Okay, so this is relatively easy and is identical to what we've seen before. A little bit more complex is the file command.run. So we try and go through command.run. We use more so we don't print everything at the screen right now. There's lots of things in these here, but we want to look for the function that is called the Nextflow launch. So I searched into the file using / and then writing the string I wanted to search. And this has skipped the whole file and brought me to this one here. This is the way Nextflow runs the command.sh file. So the command that we just looked here expanded with the variable through Docker. So now you can see that the command that is actually have been executed in our host machine is very similar to the command that we used in order to test our cowpy command. So we have Docker run interactively. There is a definition of resources that are being allocated. More importantly, you see that there is a volume mount here where we mount the work folder into this path here inside the container. The name of the container is this one here, which corresponds exactly to the container we instructed the module to use. And then we are running a bash shell script that is command.sh inside the hashed work folder that we have just accessed. Okay, so that's the most important thing. Recap of what we have seen until now. So, number one, methodology. We want to use cowpy. Cowpy is available not in the environment we are running right now, so we need some tool to import or to use a software that doesn't exist in our environment. The most robust way of doing this in a portable way is to run through a container. We can find a container using Sequera containers, which allows us to build on the fly containers with the software we need, knowing that if someone else has built the same container with the same software before, we don't have to build it from scratch again, and we are going to use a container that exists already in the repository because someone has built it before. So recycling, reuse again. Second, the software must be tested before we write the process. So what we have done in the first place is to pull the container with the Docker pull and then try to run the command we wanted or we thought we wanted to put in our module through this container. This is done interactively with Docker run -it. And then if we want to use a file that exists in the host system, we need to mount as a volume the folder where the file exists, so it can be found inside the container when we run a software that exists inside the container. Okay? So that's the basic, and this is what we are going to port inside the module when we create the module. In reality, it's even simpler because this execution through Docker is something that Nextflow takes care for us, as we have seen by inspecting the command.run that Nextflow writes before executing the task. Okay? All we have to do in order for Nextflow to create these, let's say, complex file for us is simply instruct the process to use a container in order to run the instructions in the script block, and then write the script block exactly as we would do if the software existed in our system. If we do this, then the rest is identical to what we have seen before. We simply include the module we have just created that makes sure the workflow can call for this module. We call the module with the inputs that we have defined in the module exactly in the very same order. And then we simply run Nextflow workflow as we have defined. And this ensures us that the software is found, that the script is executed as we intended, and it is executed through Docker without us worrying about writing the whole command line with Docker run, with all the volume mounts, and so on. We just worry about the command, the instructions we want to run, and the container we need in order to find that software. That is everything for this part. Before leaving the floor again to Marcel, we do have some space for questions or also feedback from you, in the sense that we could complete this part with the next part that Marcel is about to run, unless you are particularly tired, but just tell us what you prefer. If there is any question, I'm happy to answer any question. Otherwise, I will simply pass the floor to Marcel.
Yeah, so the next part, we're gonna talk about configuration. But if there's something we already mentioned and you want us to go deeper on that, explain something, we can use the remaining 30 minutes to talk about this. Otherwise, we follow with configuration. So it's up to you, up to the audience to decide what you're gonna talk next. What you're gonna talk next. So comments, we have 14 people online.
Unless we have dosed everybody already.
Okay. Unless
okay, then maybe we can proceed on. This is going to be recorded anyway, so it's going to be useful to everybody.
Exactly.
All right.
Okay, so the 60th and last part of the training is the configuration, which is something that we have discussed a bit since the beginning, but superficially. And now it's time to go a bit deeper on that. So let me share my screen here. Okay, so the first thing is, I think it was in the very first part that Francesco was talking about parameters, and he mentioned the precedence or priority of the configurations that you set to your pipeline. And when you go to the Nextflow official documentation, docs.nextflow.io, if you go to configuration, the first thing it shows you is exactly this precedence. So as Francesco mentioned, when you specify a parameter on the command line, this is the highest priority, right? And then the second one is a parameter file that you provide. You're gonna see this today, or a whole configuration file, the nextflow.config in the launch directory, in the project directory somewhere else if you're running from other place, right? And so on. The lowest priority is the configuration on the main.nf file. So when you have conflicting configurations, like one place is saying Docker enable true, another place is saying Docker enable false, which one Nextflow is gonna pick? It's based on this priority list here, right? This is the first thing that I wanted to mention, right? Okay, just like in the previous steps, we're gonna open a file which is called hello, and then part name, which is hello config, right? Which is the exact, where we exactly stopped at the step before, right? I created a call pipe following what Francesco was showing. So let's just run this Nextflow pipeline with resume. Oops. Yeah, it had worked. With, oh my God, I'm typing. It's a bit laggish here. 1 second. Okay, now it should work. I'm gonna run again with resume, and there's an error. What's the error? It's saying that copy is a command not found. The thing is, if we go to the module, everything is fine over there. You know, it has the container information. So the reason that it's not using Docker is because we probably have Docker enable false. We haven't configured Nextflow to use Docker. So when we go to the nextflow.config file, indeed, docker.enable, it's saying false. If we set this to true, then we can go here, run it again, and this time it's going to work. The copy command will be found because it's run inside the container. Really quickly, because I had already ran this before, so it's cached. But otherwise, it would take a few seconds to run the container, bring it up, get inside, run, move files around. Then it would take a bit longer than the other steps that are just local, right? So, good. It's important to say that if we go to the Nextflow documentation, right, and you go to the section on containerization, see the container. You're going to see there are many different technologies, right? You have, probably it shows here, you have Apptainer, you have Charlie Cloud, Docker, Podman, Sarus, Shifter, Singularity. And this means that Nextflow has native support to these technologies. What does it mean to have native support? It means that if you have in your CowPy file the container directive with the image here, that's it. You just have to say here in the Nextflow.config if it's Docker enable or Apptainer enable or Singularity enable. And even though all these technologies, they work differently, they have different commands, they behave differently, it doesn't matter because Nextflow knows how to translate everything to each of these technologies. So you just have to say which one you want. And here we said Docker, and the rest is going to be taken care of by Nextflow, right? This is the thing. However, apart from containers, you can also use Conda environments or with containers. There are many other different ways to solve this dependency issue that you have. You don't want to install software in your machine and you want to run the pipeline. So another solution would be to use Conda. So we do Conda enable true, and then we have to make Docker enable false. And by doing this, we can run our pipeline. The issue, and there's going to be an error, is because, again, command not found. Why? Even though here in the CowPy module, we specified what container image we are talking about, we haven't done the same for Conda, right? So you can go to the Conda website or even to the Secure Containers website and see what's the name of the package, but I already know this one by heart, which is in the Conda Forge channel. The name is CowPy, and I want the version 1.1.5, right? So by doing this, now finally Nextflow knows how to run this pipeline with Conda. I set the Conda here, the Conda channel and package and version. In the configuration, I set Conda enable true, and now I can run this. And this time it's going to work. It's going to take some time because it has to create the Conda environment, download this file, solve dependency that it may have. It may depend on other software, then you have to check for conflict and everything else. So it takes a while to build the environment. And then finally after that, it will have the environment and it can run the task from this process in this environment. You could also differently provide here a file, a YAML file with the Conda environment. It's something that we saw in the NF core modules, right? The environment.yaml file. Or you can even use other things like Wave that you can check in the documentation. It goes a bit out of the scope of this training, but there are other options you can check also, right? Here it worked. Good. So for managing the installation of files, among other things, that's what usually you're going to do. You either set here the container or spec or Conda directive. You're going to turn it on in the Nextflow.config, and it's going to be just fine. So this way, using containers or Conda, I can use this on my computer, on your computer, and it's supposed to work just fine. The thing is, oops, not this website. The thing is, because of the way that Conda works, it may be that in your computer, or in my computer, we have a different way of the way Conda solves these packages, right? So because of that, we can also use Conda log file. I just want to mention this. I don't want you to do this now because it's a bit more intermediate level, let's say. But it's important to know that we have this Conda log files to ensure consistent behavior across Docker environments with Wave and Conda and so on. And basically the secret here is that you're going to have your environment YAML file with the environment that you want to create, right? But you also want to create a log file. And the thing is, when you want to create a Conda environment, it's going to look for these files, check what files you need, solve for conflicts, organize everything, and then create your environment. And the thing is, because of the way that Conda works, maybe if you do this in a month, the way it solves these dependencies is going to change. And this can lead to different versions or problems, right? So the log file basically says, the way I solved this today, save it. And next time I want to build this Conda environment, just follow exactly what I did today. And then you can have this consistency. What I'm saying with all this is that even though you can use Conda and you can fix this limitation, the gold standard is to use containers. And that's why we have a hello container section and not a hello Conda, because even though lots of people use Conda, containers are the gold standard, okay? Leaving a bit this part of package management and environment, let's talk a bit about compute resources, right? Even though we can run these pipelines in our machines, in our laptops, in our desktops, and it's just fine because we are training, we are testing, we are developing a pipeline, that's fine. When you want to run your pipelines for good, usually your computer doesn't have enough resources for that. So you're gonna run your pipeline on a cluster of your institution, a supercomputer, or on the cloud or something like this. In these environments that are these shared environments where multiple people use it at the same time, it needs to have a way to manage the resources so that everyone can be provided with the computing they need. And usually this means that whenever you want to run something, you have to tell them. So if you have a Slurm in your cluster, Slurm is a software that is a workload manager for clusters, right? So if you have Slurm in your cluster, basically when you run any code, it's not only a pipeline, any program through the cluster Slurm system, you have to say, I think I'm gonna need 2 gigabytes of RAM, 2 CPUs, 1 hour, and this should be good. And based on what you need and your priority on the list, you're gonna go now, or you have to wait until someone else stops their computing, right? If you go to a different cluster with a different technology, this means the syntax and the comments, it all changes. And it would be ridiculous to expect that you know all the commands, all the syntaxes, all the cloud providers, everything. So you don't. Nextflow does that for you. You just say, Nextflow, I want 2 CPUs for this process. And wherever you run your pipeline, Nextflow will convert this request for 2 CPUs to the language the workload manager or the cloud provider expect this information as, okay? So for example, let's open again the nextflow.config file, which is the main configuration file, right? And I'm going to start allocating some resources. So I'm going to say that for all processes, I want just 1 CPU and I want 2 gigabytes of RAM. I could actually just go to the module file and put it here. After all, it's a process directive. I could just do here CPUs 2, right? And actually, that's correct way to do it. As we saw in the NF Core modules, all this information is encapsulated in the modules. But here, for training purposes, let's do it in the nextflow.config file. So by having this, basically what I'm saying is, I want 1 CPU and 2 gigabytes of RAM. Let's run here this pipeline. But now for the first time, we're going to use an option called with report. And pay attention to the 1- because it's a Nextflow option, not a pipeline configuration. And I'm going to name it report .html. So it's going to run the pipeline. I forgot the dash resume, so it's going to run as it was the first time. The environment was already there, so it was a bit quicker. We can go now and see here the report.html. Let me see if I can preview that. I don't want to see the HTML, I want to see the preview. Okay, I'm gonna download it and try to open it here on this browser. Maybe it's gonna work. Oops, not this one. This one. Okay, you can see, right? So here we saw it was a drunk Lamarck, same session name here. And we can see some basic information, number of tasks, the launch directory, how long it took, and all these things. But we can also see some plots. And here we see, for example, that all the tasks from the say hello process, which is blue here, we have a box plot. They got a median of, 45% or 50% of 1 CPU, right? Good. But how much did we ask? 1, so it's the same, that's fine. So CPU is very easy because we have 1, I ask for 1, that's good. When we go to memory, again, it was very quick. So there's not much we can do here, but we can always see like as a percent of what we allocated. So here we see that we use 0.7% the CoPy process of the 1 gigabyte that we asked for this task. So we are asking too much resource. And this means we're going to spend more money on the cloud, for example, because if I ask for a more powerful machine, it's going to cost more money. On a cluster, if I ask for too much resource, it's going to let me waiting for longer because I'm asking for too much. The thing is, if you ask for too little, it's going to explode, it's going to run out of memory, it's going to fail your task, and you have to run it again. So you don't want to ask too little or too much. You want to ask exactly how much you need. And these reports here, they help you get to what's the correct number. Or if you're using an NF Core module, amazing, it's going to give you already the number the expert tried and got to this number, right? Because it's a very simple pipeline and a very quick one, there's not much to see here, but usually what would happen is that you would see more useful information here. So for collect greetings, for example, for collect greetings, it used over 100% of the single CPU core, right? So for this one, we should probably ask for more memory, for more CPU than what we asked so far, okay? So what we can do based on that is to say, let's keep just then 1 gigabyte of RAM, but for the processes or process with the name CoPy, I want something specific. I want 2 gigabytes and I want 2 CPUs. So that's what we call process That's what we call process selectors. We say, I asked for everyone 1 gigabyte, but for processes with the name CoPy, I want something different. Or I could say processes with names starting with cow, or I could say processes with label. When we are looking at the NF Core modules, I showed you the label process low. That's what it serves for, because here we would have with label low process, ask for not much CPU. But for processes with the label high processing, I want a lot of CPUs and so on. So that's how we control these things, right? So now that we did it, we can run it again. I'm going to say report 2. I'm going to download it again. Open it here. Okay, I think it didn't download. Report 2. Oh, it's here. Is it the one? Oh, what's the name? Jovial Scoff. Yeah, it's this one. Okay, let's do something like, let's take the collect greeting here and ask for more CPUs. So I don't know, 4 CPUs. Let's run it again and see what's going to happen. And let's ask for 1 gigabyte here. I'm using the wrong one. Okay, I was looking at changing CoPy and looking at the other. But one thing here. Trunk mark. Yeah, so when we decrease the CPU, you see here now, it's using about 100%, and before it was using about 80%. So we were asking for too much. But when we decrease the number of CPUs, it got closer to using what we asked, right? So that was the point here, to change this resource request so that we have something closer to what we really need, not asking too much, not asking too little, right? Another thing that is actually a recent feature of Nextflow, I think it was last year that we did this, is the resource limits. Here, when you say 1 gigabyte of memory and Nextflow requests a virtual machine or a container or something like that, 1 gigabyte of memory, if it goes over that, it's gonna error. So say, ran out of memory. That's good, but something that some people wanted, and it wasn't possible until some time ago, was like, okay, I know that this task cannot go over 1 gigabyte, but what if I want to limit all the tasks? I want this pipeline together to never go over 20 gigabytes of RAM, for example. And for that, we have a new directive called resource limits. And for that, you can just do like, for memory, I never wanted to go over 20 gigabytes of memory or 30 days. And with that, you can make sure that whenever it's about to go over 20 gigabytes, Nextflow is going to wait until some memory is freed, and then it can ask for another test to run, right? And the time together, it cannot go over 30 days. This is just one example of what you can do with this resource limits, which is global, just to make sure, right? Well, another thing is, instead of having, like we saw before here, all these parameters where they greeting, batch, character, they have the default values here, nice. But for example, let's say that I want something else. I would have to do Nextflow run hello config dash greeting something dash batch something dash character something. It's very annoying to have to type all this. And as you saw with the RNA-seq pipe, NF-core RNA-seq pipeline, it can get very tedious. It can get very, very long. I could have 20 parameters, right? I don't want to type all them. So instead of that, I could create a JSON file with my parameters, a test parameters JSON, any name you can give, right? So inside here, we have a JSON structure with the greet parameter and the value here, batch one and the value here, and the batch one, the character one and the value here. Let's use pig. I think there's a pig one instead of turkey. So now what I can do is just run my hello config and do params file. It's one dash because it's a Nextflow option, right? And then I say the name of the file. That's why you can give any name because you're going to call it here. So instead of typing 20 options, I just type one now, and this is going to happen. Maybe there's no pig. I don't remember what are the options. Let me see. I think there's a turkey, but there were also other ones, right? Anyway, let's just keep turkey then. Okay, now if I go to results, output, I think it's collected trio output. I have here this. I think it was some other file, right? Results. I think was output? No. But anyway, it ran, right? It took into consideration this parameter file, just like we wanted it to. Something also interesting and similar to what I said when it comes to the container technology, you say Docker, Singularity, whatever. Another thing is the executor, right? Where this is going to run. As an example, we can go here to the training material so we don't have to copy paste easier. For example, if you are running on Slurm, like I mentioned, this is the script that you have to build, saying, we're long gonna go this way. I want 8 CPUs. I want 4 gigabytes of RAM. I want all these things and this queue and so on. Everyone has to write this manually. Here, if you tell Nextflow you want to use Slurm, Nextflow will automatically build the script file for you. And as I said before, the syntax is different if it's going to be PBS. So here, look how you ask for 4 gigabytes of memory. In PBS Turkey, look at how you ask for memory. It's different, right? The command to submit a job on Slurm is sbatch, but on PBS Turkey, it's qsub. On SGE, which is another one, is again different. Look how you ask for memory. So these things, they are very different depending on what the executor is. And the nice thing with Nextflow is that you just can come here to the process part, or you can go directly to the module and say it here, right? Executor. And by default, it's local, but it could be AWS, it could be Slurm, right? And one important thing to mention is that, as you can see here, whenever you use directives in the process body, there's no equal. It's the name of the directive and the value. But when you go to the configuration file, you need this equal sign. So here I would say executor local. All my processes, they're run in my local machine, just like I would run here on the terminal, right? If you say it's slurm, something interesting is going to happen. So let's delete the work folder here. Let's run my pipeline once. And if I look at the content of the .command.sh of any of these tasks, like you did with Francesco before, you're going to see what's actually run, which is inside here. So for example, let's look at the copy. So code, work, d1, f23.command.sh for the copy process, right, task. When I open it here, I have cat, collected, pipe, copy. I have a command, which is just this one here, but with the variables being replaced. Cool, right? If I go to my Nextflow config, and instead of executor local, I say executors learn, look at what's going to happen. I'm going to run it again. And again, I'm going to see the content of the copy process. Work, D1, F23. Oh, 1 second. Here, executors learn. And remove the resume. Did I save this? Okay, I got an error here. And now it's trying to run SBatch. And then it says that it cannot run this program, no such file, right? But let's see now what's inside the work. I didn't even get to get the address here. See here what's inside. I delete the work directory, run this again. And let's see if there's something here. So work 3E. Oh yeah, that's the thing. Because I said process executor for all of them, at the first one, which is say hello, it already gave an error, right, about SBatch. If I open this .command.sh, this is wrong, I shouldn't delete this. Oh, sorry, the .command.run was, sorry, confusing it. Okay, so just so that it's not confusing to you, I'm going to repeat it from the beginning, right? So continuing from where we stopped, let's do something. I'm going to clean my work directory so it's easy to find the files. Let's run this pipeline once with this configuration. The executor is local, which is the default one, right? So I create the Conda environment for the cowpy package. We are using Conda, not Docker. That's the configuration for all the processes. I want 1 GB of memory, but for the process name cowpy, I want 1 GB of memory and 4 CPUs instead of the default, right? I also have some resource limits for the whole pipeline, and that should be fine. Just ran. One thing that we can do though is let's go to the work directory. I'm going to look at the task of the cowpy one, right? So 73, 56. I can press tab and complete. And I want to look at the .command.run file. At the very beginning of this training, you checked these files with Francesco, and you saw that the .command.run is all the work that Nextflow does under the hood, right? So if we had Docker in NXF run, NXF launch, we would have here the Docker commands and everything else, but because it's just a command that we want to run locally, and we are not using Docker, we're using Conda, it's just going to run this .command.sh that, as we saw earlier with Francesco, is just the command that we want to run for the cowpy task, right? If we look here, we can also find some Conda things. We are searching this Conda environment that was created. So as you can see, the .command.run has all the commands that you don't have to know because Nextflow is going to take care of for you. The thing is, if instead of executor local, we say slurm, which is a workload manager. I think I mentioned this already. So it's a workload manager. It's going to help you manage all the resources in your cluster to all the different people that want to use it, right? The thing is, In order to do this, you have to tell Slurm or your cloud provider, AWS, Azure, Google Cloud Platform, PBS Turkey, which is a different workload manager for clusters. All these different technologies, they have a different language, a different syntax, a different way of doing that. And if you run again our pipeline now and check the .command .run of any of these tasks, we're gonna find the Slurm syntax. Here there's an error because it's trying to run SBatch and we don't have SBatch installed in this virtual machine, in this environment. The thing is, SBatch is the command you use for running jobs to Slurm, right? So let's look at the first test that failed, which was to say hello. I'm gonna open work, this here tab, .command .run. And as you can see here, the beginning of the file is quite different. And if you check the training material, you're going to see that this is the syntax for Slurm. To tell Slurm how much memory you need for this job, you say SBatch --mem, and here you have the memory, and then you have other information here. But for example, if I wanted to use PBS, I think it's the right word, let me see here. PBS Turkey is another workload manager for clusters. Here, the qsub command is not installed, but you see, it's a whole different command, a whole different program. And again, if we look at the task .command .run, work command run, you're going to see a whole different syntax. Instead of --mem, now we have -l mem equal 1 GB, right? So the whole syntax is different. If you had to memorize all the different syntaxes and commands and parameters and configuration of all these different environments, I mean, you'd be in trouble, right? You should be able to focus on your analysis on the bioinformatics or whatever field you are working on. You shouldn't have to worry about all these different things, Docker commands, conda commands, package names, channels, and all these things. So Nextflow is going to take care of this for you. That's the point I'm trying to raise here, right? And if we do, let's do again now, instead of using conda, let's use Docker again. And then I'm going to show you how it looks like inside the .command .run. I'm going to get any of them because we use our open. We didn't provide a container directive for the other ones, so let's look at the CowPy because then we did. Just to remember you, if we go to the module file of CowPy, we're going to see this container directive here saying what container image we want to use, right? So now let's go to work, 5E, 8B, tab to complete, .command .run. Now, if we look for conda, there's not a mention of conda in this file because we're not using conda anymore, we're using Docker. If we look for Docker, now we see lots of things. Deleting the container at the end on exit. When launching, we're gonna run this Docker command. We're gonna ask for 4 CPUs and 1 GB of memory. And there's gonna be a work there. And we're gonna mount a volume, as we saw in the hello container section, where the container will be able to write to the host machine. And the host machine is going to be able to find these files and all these different things, right? So this .command .run is not usually a file that you look at because it's just a lot of different things that usually you're not expert at, right? Usually what you want to do is to look at the .command .sh because then you see the final command with all the variables relates what was really run, right? But if for some reason you want to investigate how it was run, if Docker is being used as you want or conda, or if it's converting the script to Slurm and everything else, then you want to check the .command .run, right? So you saw here that we can have a very diverse set of configurations. I could have all the processes with one amount of memory that I want for them, each task of them to have 1 GB, but maybe one of them with the name CowPy. I want a different configuration, research requests, or maybe not only with name, I could have with label. And then I would say any name like low CPU process. And then whatever process I have, let's open here again the CowPy, for example. Whatever process that I want to pick this process configuration, I just do label low CPU process. Every process that has this label will automatically pick this configuration. This is what we call a process selector. So you can select processes based on name, part of their name, like all the processes starting with big, for example. and also a label, right? So this can get very complex. But let's say that I have this pipeline that sometimes I run on my local machine for testing, sometimes I run on the university cluster, sometimes I run on the cloud, sometimes I don't want to really run it for good. I want to run like a test with a small sample size and things like this. Do I have to all the time come here and change this, or have different configuration files and have to pick them with a -c parameter? This is not very useful, not very nice to do this way. What we can do is to use what we call profiles. So you could have here a profiles group, and then I would say, my laptop, which is usually I want to run just to see a few things, I could say that the process executor is local, which means don't add anything complex to the .command.run, just run the commands as I say it, because it's locally, right? But I still want to use Docker. So I don't want to install all these packages in my host machine. So I'm gonna say Docker should, and that's it. So I could also say, process memory equals 1 GB. Cool, that's it. But then I could also want to have a profile for my university HPC, right? And for this one, it is Slurm. And I want to use Conda, not Docker. Some clusters, they are resistant to use Docker containers, so they're going to use Singularity or something else. Here, let's say we use Conda. Then, let's say we want to add some resource limits. And here, because it's a cluster with a lot of resources, it's not my laptop, right? Let's do 750 gigabytes. And that's it. So now what happens is that when I run this pipeline, I can say dash profile. It's one dash because it's a Nextflow option, right? Dash profile, and I can pick one. And I'm gonna say my laptop here. And it's gonna run just fine because I have Docker installed, I have the container, everything is just good. But then if I say dash profile university HPC, now it's gonna fail because we don't have the Q sub for Slurm, right? The S badge for Slurm, right? So it's gonna fail. But you see, just by saying what profile I want to use, the whole configuration changes. And I could have partner university profile, which uses PBS instead of Slurm. And you see, all this is decoupled from the pipeline. You don't have to change your pipeline code. The pipeline script, the programs you use, how you use them, what commands you type, everything remains the same. The only thing that changes the configuration, this is completely decoupled from the pipeline, and you can just pick it with the profile. Another thing that you can do is here, for example, we have this params greeting, right? Saying where the path is. I could have a test profile. And for this one, the params greeting will be, let's say, a path to a small greeting file, right? And I still want to use Docker enable true. And this is interesting because one thing I can do is to choose my laptop, but also by adding a comma, another profile. So you could have multiple different profiles at the same time being used. And that's the power of these profiles in the Nextflow configuration, right? If you go to the NF Core website and you go to, let's look for RNA-seq, which is a pretty common, very famous Nextflow pipeline, what happens here is that you can go to usage and you're going to see a lot of different profiles. Let me see here, profile. Here in this example is suggesting you to use Docker, and I'm sure there's another example with more profiles. Here, not here, okay, let's look for the test. Okay, here, for example, it says, if you want to use Docker in the test data, you can use profile test, Docker. In all the NF Core pipelines, they have this test profile, and they also have a test full profile. Let's look at the source code here. NF Core RNA-seq. If we look at the think it's here, conf. You're going to see this testflow.config in this test.config. The thing is, the nextflow.config file of this pipeline, it includes all these other guys. So let's look at nextflow.config. When we come inside here, you're going to see, let's look for tests. So this is the whole profile. Look at the number of profiles that we have. Here, profiles, we have a debug profile, we have the conda one, we have the member one, we have all these different ones, right? And when we get to test, it includes a whole configuration file. For test, here, it's a small one, 4 CPUs, 15 gigabytes of RAM, 1 hour, you know, it's a test profile, it's a minimal test data set. We have here some sample sheets that are small. If you can open this file here, for example, I'm not sure if it's going to render in the browser. Yeah, you know, it's very few samples. If we go to this one, this is the full test, right? And then it says a full test data set. It's expected to simulate a real run. And if we open it here, we have bigger samples. It's not the number of samples, but they have bigger ones. Sometimes we have part of a chromosome for the test and the full sample, the full genome for a full test, right? And with that, you can make it the configuration like it's up to your creativity, right? It's infinitely possible to do anything, many different profiles, a profile you use, a colleague uses with one genome or reference genome or something else, right? With that, we conclude this last part of the training, the part 6, the hello config. I would like to thank Francesco for the part that he took care of. I think the introduction was very important. At the end, at the beginning, the slide decks were very nice. I'd like to thank you for all the questions that you asked, all the participation during this training. Seth for hosting it as with ISCB. And thanks for this opportunity to spread the word about Nextflow and F-Core and reproducibility in data pipelines. Thanks, Seth.